Good morning, everyone. Okay, we have the third day after having really 2 full days behind us. As you know, on Thursday, so today we do a lot of demos, workshops, so to see a lot of practical things, basically how to apply the theory we studied in the previous 2 days. And first to do the job is Silviu-Ionut from CGRates, yes? And okay, he will show us this real-time CDR analytics with CGRates and the family Prometheus plus Grafana. Thank you.
Thank you. So, as you this is my first time presenting, so this is the... for the demo today, I will take a bare Debian 13 machine with nothing except very minimal SSH setup and sudo, passwordless sudo, so the setup goes smoothly. And in the end, we'll have a complete minimal CGRates setup and a Grafana dashboard where we can see the metrics and runtime metrics, CGRates internal metrics, and cache stats and so on. I did this last minute, so I'm sorry, it's terminal pictures. But, so the basic idea is that the traffic will be generated by Sippy. So I have a user agent client that sends invites to a server via an OpenSIPS proxy. The setup is a bit unorthodox because I initially planned to do it on master v0.11, which is proven to work with OpenSIPS, but I decided to go through with 1.0 in the end. The problem is that 1.0 has a different APIs for sessions, which is the entry point into communicating with CGRate. So I had to do it a different way than usual. Also, since on 1.0 prepaid is not yet functional, it's a work in progress. So we just do offline CDRs, and they get and we send the process event on byte the moment the UAC sends byte to the UAS, and we send the request, and then we update metrics on every we update metrics and rate the CDRs and store them in the wholesale way. On the other hand, we have the Prometheus, which scrapes CGRates on fixed intervals. I configured 5 seconds just for the sake of this demo. But the thing is, the metrics, the dashboards are not that clean looking. So we also use Grafana, and we query Prometheus via PromQL. And we'll see at the end how they all look like. So I'll start by doing the installations. Please tell me if the screen is the text is too small. So I have a reference file that I'll use just to save some time. So from the beginning, even though it's the setup is not finished, I'll just set up an SSH tunnel because to access the Grafana and the Prometheus from the local browser. So this is, I can just leave this here. So 1990 is for the Prometheus and 3000 is going to be for Grafana. I can just open them right away. There's nothing here, and this will show when the setup is finished. So I have some configurations that I prepared beforehand. I'll copy them on the demo VM, and I'll start by installing CGRates. Actually, just to not write every time the full path to the config files, I just set an environment variable beforehand. Actually, I'll put it just to be safe in VRTC. Okay, so now I'll start by installing CGRates. I'll just use the steps inside the documentation. So documentation can be found on cgrates.read.docs.io. I'll install, even though I have Debian Trixie, I'll be installing the book one version. It doesn't really matter, it works. I did the same for OpenSIPS. I'll do the same for OpenSIPS. So just and while they are executing, I can just go through the installation process. Like we just get the key, then we add the sources, so we know which version to get. Like we get 1.0 from book one. Then we update to make the source for apt to see the source, and then we just install. I can check the version like this. It was built yesterday. And also we can this way we can check that it's functional. So there are quite a few open files and coroutines right away, which is more than usual because by default now on 1.0 we use internal database, and recently we added persistent storage, which we write on file every interval, like I think it's 1 minute by default, but it's configurable. So for each component, like CDRs, rates, stats, thresholds, we have like a go routine, and also we have open files that we are connected to. So it's that's why the number is higher than usual, than what you might be used to. Then we can use we need to set it up. This CGRates is currently running because, but with like a default configuration, it doesn't do anything. So right away we can, I'll provision the configuration, and then we can we'll look over it, like to get a general idea. So what I'm doing is I'm copying the configuration inside the etc CGRates.json path, which is the default place where you configure when you install via packages. It's configurable via daemon opts, I think, an environment variable, but it's not the purpose of the presentation, so I'll continue. I create right away some tariff plan folder because the actually I just do it and I'll just go and show you the configuration right really quick. So, Node ID, OpenSIPS demo, this is just cosmetic. We'll have, actually I'll just, as you've seen in this slideshow, and this setup picture, we need to have sessions enabled because that's how OpenSIPS sends request will send request to CGRates. So we just enable sessions and we configure a connection to CDRs because we'll use CDRs to actually forward the events to stats and rates for metrics and rating. Actually, it looks a bit when we put it on like this. So, since session is connected to CDRs, that means that we need to also enable CDRs also. CDRs will have connection to rates and stats. And some OPTs which are defaulting to true now with on the new version. We use one API for everything. We will use one API for everything. The others are still there currently, just for testing and backwards compatibility in one way or another. In opts, I will. So it works with flags now. If you're familiar with previous versions, we had different signatures for all the APIs. Like we had sessions v1 authorize event, sessions v1 initiate session, sessions v1 update session, and so on. And each of them had their own flags and the event. So now it will be like just an event, and we have a new API ops field in which we can just configure everything there. Like we want to authorize, we can just have a meta authorize, meta meaning the star in front, star authorize a flag, or if we want to initiate and save the state of the sessions, we can do star sessions. Star initiate flag and so on. Like also we can configure what subsystems, for example, in this case, CDRs communicates with. In previous versions, we check, for example, as long as the connection is configured, we send the request there by default unless we disable it ourselves. So this means it looks a bit different now because we have dynamic opts on 1.0. So that means now we are hardcoding the values to true. So that means always, regardless, CDRs will send requests to rates and stats. We can disable it if we hardcode this in the event. So, for example, if we have so the events look something like this. So tenant always CGRates work. ID is something random just to identify the event itself, not related to the session or something. Then we have event, which is the same as usual, and now we have APIOPS as well. So inside APIOPS we can pass the flags just like this. Stats or and it will override the configuration that we did here. So the API has precedence over the configuration, and then inside the configuration we can also do via filters. So for example, rates we can have we can send if the tenant is CGRates.org. We can have true, and otherwise if tenant is CGRates.com, we can have false. So it's configurable. It can sort of be used like a dispatcher. So we, based on what the event holds, we can choose where to forward the request, like because this is a modular. This is built in a modular way, so we can have like CDRs component in one engine and then a rates component in another engine, or we can have multiple engines that have rates, and we can forward requests to many of them individually based on our needs. So for now, like we for now we will just stay with our always true value just for the sake of this demo and simplicity. Now, since CDRs is connected to rates and stats, also the same applies. We have to enable rates, we have to enable stats. I'll actually open also another one to show the tariff plan configuration. So the main idea is that we will have 3 StatQ profiles, and what we will be tracking is ACD, which is average call duration, TCD, which is total call duration, ACC, which is average call cost, TCC, which is total call cost, and this star sum #1 is one of our metrics that we can either pass constants to it, like 1 in this case, which just adds 1 for every event that we process, or we can have like a variable field that we take out of the event. So star it would look something like star sum. We look inside RAQ, which is the request, and I don't know, account, for example. Account is not a number, so I don't know, usage. So this is sort of like total call duration. On 1.0, this usage is in the APIOPS, but on master, for example, usage was passed in the event, so you could do something like this, which is just similar to TCT, a predefined one for simplicity. So all of them track the same metrics, but over a different period of time. So we have one that tracks them over the last 5 seconds, which has a time to live of 5 seconds. 1 second, let me open it in editor. So queue length is 0, which means unlimited. Time to live is 5 seconds, which means every the items that we track for the time, they are stored only for 5 seconds and then evicted, and their value is removed from the calculation. And then we have minimum amount of items before starting to track. It's 0. Then stored through to, otherwise it would just stay in cache, and once you restart the engine, like all the metrics would be removed. Meta none for the threshold IDs. We don't need thresholds for now. They could be used in case I don't know, on a certain total call duration that is too big. You would want to do some action, to trigger some action, but we won't be using thresholds today. So we have the same setup also for the next one, but the only difference is that the time to live is 30 seconds, so we'll just aggregate events for 30 seconds. And the last one is is for the duration of the entire, it's forever. So one thing to note here is that we put -1 queue length and -1 time to live. This triggers something that we had to add recently, I think 1 or 2 years ago, because the permanent stat queues, if you keep tracking them and keeping count of the metrics, they would be a memory hog, so they would use quite a bit of memory at some point, depending on how many events were processed, and over what period of time, what load do you have on your setup. So this way we don't keep track of the items, we just calculate, and because we don't need the actual value when we don't need to worry about them expiring and remembering their value to recalculate the metric itself. So this one basically always has just keeps track of one item that gets updated constantly. There is a way to reset it via API. If like it's not mandatory to set it once and then you have to remove it if you don't need it anymore, or if you want to reset it. We have actions and stuff like that. So this was for the stats. We also have some rates. Defined now. The nice thing about 1.0 is that I only need one file for the rating setup. I won't need to define rating profiles, rating plans, destination rates, and so on. I just have one file with everything. It's a very simple setup. I will have only destinations. I will have like 15 destinations set up. 3 for each prefix, so 3 destinations start with 2, 3 destinations start with 4, with 5, with 7, with 9, and so on. And we'll apply the rate based on prefix. So we check the destination in the event, and if it starts with 2, we apply this one. If it starts with 4, we apply RT4X. If it starts with 5, we apply RT5X, and so on. meta free here means that on max cost we don't do anything. We didn't configure max cost. We could choose to do some action, but it won't be needed for this presentation. Rate activation start. This is the cron expression for always, so it will always be active regardless. You could make rates. Certain rates or only work on Mondays, or only work on the first of the month, or only work on, and so on. It's configurable. Then weights and blockers we don't need, because we have one rate per destination, and then we have rate interval start. That means the rating begins at the very beginning at 0 seconds. Fixed fee is not the case. Then the recurrent fee, this is what will be charged. So, for example, for the first one, for the RT2X, we have 0.005, which will be charged per 1 minute, which is the rate unit, and in 1 second increments. That means every second this rate will charge 1/60th of 0.005. And the same for the others. They are all the same. The only difference between them is the recurrent fee and the prefix filter. Currently we didn't load yet. We just applied. Actually, I just continue with the configuration because I left there. We configure rate prefix index fields as you remember here. Since we filter by prefix on destination, there's no point in querying the entire database. We have filter indexes which work something like you save. You look at the event, for example, you see destination that starts with 5. You look, is there any profile that is that has this filter? We save sort of like reverse indexes. We save the filter indexes, and the value of those is the profiles themselves that we want to match. They are generated automatically regardless of the setup, but you can configure which ones to look for. So, for example, we set up destination because we want to ignore all the other events in all the other fields in the event. I'll go in a bit more detail later when we do the one call, just to showcase everything. Stats. This one has an empty string index field. If you remember, stats doesn't have any filter at all. Those profiles that don't have filters, we index them also. It's a special index. So we just for stats we just disable looking for any index. This one, the one for empty ones, is always considered. Also, I'll show you what happens if you wouldn't have this one. I'll open the configuration, the default configuration. Default. Instance. It should be better to. Okay, so all the components that have that require matching, that have filters, are indexed the same way. By default, we enable indexing for all the components, and notice that all of them are empty by default except the string index fields, which we keep it commented. So because as a special case, we want to check for every field in the event if it has any profiles under any type of index. In this case, for stats, we don't want that. We want, since it's indexed always and for no filters, we just want to avoid any memory leaks. I'll show you on the dashboard later what would happen if we didn't have it. So after stats we have the Prometheus agent. So the way it works, we don't, since Prometheus only scrapes on intervals, anything that happens in that interval between the scrapes, it's not recorded. So the way we do it, we try to keep it detached from our components, so we can have it in a modular way, like all the others. The way it works, we on every HTTP get that Prometheus sends to our HTTP port, we trigger based on the configuration. We trigger some API requests. For example, here for stats, here we have connections to everything because we want to we get the computed stats. We get the cache stats, which is like how many items are in cache. This is useful to find leaks. As I said, I'll show you I will show you an example of a memory leak later. I have CoreS, which gets the runtime metrics, and admin-S, which is not really, we don't need it for to query metrics from it. It's just if we don't mention any stat QIDs, we query for all of them, so we need an admin-S connection to retrieve those. So an example, the default configuration of Prometheus agent looks like this. The path is /Prometheus. Usually it's expected to be /metrics in Prometheus configurations as a default, but it's colluding with our stat metrics, so we have to change to Prometheus. By default, all the connections are disabled. We can, if we set a cache connection, we can also set cache IDs. If we don't want all of them, by default, if we leave it empty, we get all the cache stats, and same with stat QIDs. It's the same behavior. We can, if we don't want all of them, we can just mention here in the form of tenant colon ID. What else? Loaders. We need this to load the actual tariff plans. We mentioned the path, and then we have just an API that will trigger loading from this path. We had to do it beforehand because otherwise you couldn't. The configured folder needs to exist beforehand. With index means that we always recalculate indexes on every load, and the stop on error false allows me to not create empty files for everything, because loaders loaders allows to have dynamic loading, so we have the schema already configured by default, but you can use any schema you want. So if we have, for example, defined a template for attributes CSV, and if it doesn't exist, it would error, and I just disable stop error. Now I'll explain more on the way. I'll continue with the setup for now. I'll skip OpenSIPS for now. I'll install it later because I want to show the Prometheus metrics first. I'll install it via tarballs because I think the Debian package is a bit behind. So I'll just I'll install it in OPT. I just get the tarball, I unarchive it, and then I remove the archive, and then I rename to something simpler, so it's OPT Prometheus, and not this long path. Then we create a system user. We provision the configuration that I prepared, and we create the data folder where it will store all the metrics that it scrapes. And then we change the permission so it's accessible by the user we create. Then we just put the systemd file, which is it uses the binary directly from OPT Prometheus. It specifies the config file that we provisioned. Then this is the path where the metrics will be saved, and this is the address that it will be listening on. The configuration is also simple. I'll go really quick through it. So the scrape interval will be 5 seconds for the purpose of this demo. We have to specify here the metrics path because it's not the default /metrics one, and the target. It will be the 2080 listen port, the HTTP listen port of CGRates. The notable ones are 2012 by default, they are configurable of course, which is for JSON RPC, 2013 which is for GOB-RPC, 2080 for HTTP, and 2014 for the session one, which OpenSIPS uses to connect to it. So this was Prometheus configuration. Now I can probably reload the Prometheus page, and we can go ahead and get some metrics. For now, there are no start metrics because we didn't process any events, but we have the runtime metrics that we can open an encrypt. I'll show you how they look like. Just this one for now. Install encrypt. So every 5 seconds, actually I'll also add the 2080 port because that's where the scrape begins. So we get the scrape request from Prometheus. It's from to the 2080 port. And automatically, Prometheus agent will send requests to all the configured connections. Here it sends to cache to get cache stats. These are all the cache statistics. To get stat queue profile IDs, which it fails because so it doesn't have anything to scrape from it. And then the core status metrics, which is runtime metrics for debugging or the general health of the engine. So here you can see go routines, keep memory. Actually, I'll just query for one of them. Go routines. Execute and 5 minutes. The number of coroutines is 125. It's static because nothing is going on currently. I can add another panel for heap memory. This is the allocations that happen inside our application. These two are usually the most useful ones when debugging a leak or something that's going wrong. As you can see, this is the garbage collector every once in a while. The memory keeps growing because we send requests and we allocate memory for the objects during those requests, and it keeps growing, and then the garbage collector gets rid of anything that is unused. But this one is Prometheus is stuff to make it to look nice, to present the information. So for this we'll also install Grafana. Let me so the Grafana is installed exactly the same way. Also Tarbol, also the same way to set up the system. The service just different flags. I'll go through those, although I don't know if I have time. I see I have 10 minutes left. So I have the system users. And now I put the system DA file and restart. Now we can check also on the Grafana port that if everything is fine. Maybe need to delete a bit. Okay. So the default logins are admin and the browser graphical user interface. We go to dashboards, to analytics. Currently we have nothing for the stat metrics because we didn't process anything, but we have for cache. I think this one is for RPC connections. So and also we have the runtime. I chose only the most important ones for this for the purpose of this presentation: the coroutines, the heap memory, the sys. The heap sys memory, which is how much the application requests from the OS. Usually it grows as the memory usage grows. It stays static until the heap memory hits the same level or higher. The RSS memory is what the system allocates to. It's usually higher. But but it's just external stuff. The ones that concern our applications is usually the most important one is heap alloc. But this is what you see. The RSS memory is what you see when you run a command like top, and you see and it's the same value you see in there for the CGRates application. Also there is cumulative, this is the SQ total which we don't have yet. So now I'll go really quick and also install OpenSIPS. very minimal configuration that I did. I used the stock configuration that comes pre-installed once we install the Debian package. I did 5 changes, so I don't know if I could show really quick before I give VRTC OpenSIPS. So I removed any, sorry for this a bit ugly, but I work with what I have prepared currently. So I removed the accounting module because the source of truth, we need only one source of truth, which is CGRates in this case. I need the dialog and the CGRates module. CGRates module will be used to send the session SV1 process event request. The dialog is needed to keep track of the timestamps and everything. Also, we need the record route module to have loose routing because we need to go, the invite and buy, we need to go through the same proxy. And to remember, so for on invite, which I'll scroll below. So we removed anything related to accounting, and for this we replaced with actually I'll just show in the editor. So on a successful on an answered invite on a 200 OK, we trigger this branch, the handle nut, and there we have this logic. So we check the status, and if everything is okay, we add the timestamp to the dialog value answer TS, which we will use on buy to calculate the usage for the event. So we do on buy, we will get the answer, the timestamp that we saved on the 200 OK, and we will calculate the duration by subtracting from the current time that answer time. Then we put the from URI as account, then the to URI as destination, answer time just for the sake of documentation. And OpenSIPS is the CGRates value that was used previously for flags like get max usage, true, process thresholds, true, process attributes, true, which would enable would enable certain functionality for the individual session APIs, like initiate, update, terminate, and so on. I managed to I kind of put it together to look as a JSON. I put the call ID, meta origin ID. I put the calculated duration under meta usage, and then I enable CDRs via flags with meta CDRs true, and then send the request. This is synchronous, so if CGRates goes down in the meantime, it might block, I think, but we'll see a bit later. But this is it. This is all the changes that I've done. I removed the counting and I did this logic. Now since everything is set up, I think I just need to load the rating profiles and the stat metrics, the stat profiles, and I can start encrypt on in 2014 because this is the entry point. Actually, we can remove 2080, 2014, or 5060 to see also the SIP traffic. So now I can just register the destinations to install Sippy. So we send register request, so the OpenSIPS proxy is aware of the destination, so it can replace once it intercepts the UAC request. So we send register, then we open the UAS in the background on port 5062, and then we send just one request, and it should go through. Then we can check the ngrep really fast. So it's the duration is variable between 500 milliseconds and 20 seconds. It's finished. I can close the ngrep. I can start the traffic for later, so you can see in Grafana some stats. I'll do 2 calls per second for as long as it takes. Now we can check the ngrep really quick. So we get the invite. We from the UAC to the proxy. Then the proxy says it's giving it a try. It will forward to the UAS. Ringing. Then it receives the 200 OK, and it adds this record route header. This is where we save the dialog timestamp. Then the call goes through, and these are calls from Prometheus. We don't care, and we're looking now for the buy. So here we get the buy. The buy immediately triggers this sessions process event request, which is what was created in that. Okay. Which was what was created in the OpenSIPS configuration. We have meta usage 12 seconds, CDRs true. We see the call that it makes to CDRs process event is the same event. It just added a different ID for the event, but it's basically the same since we don't have any attributes that modify it. Then CDR sends the call to rates, which gets back which calculates the cost. Here the cost is 0.01000. So and then we send to stats process event as well. This one returns the profiles that matched. All of them match because they don't have any filters. So this is now we can check how they look like on the Grafana dashboard. So since I'm running the around two calls per second, it shows here that the average is the last 5 seconds stats are 11, 7, 11, so on. So it's accurate. Same for the 30-second window. It's roughly twice the amount of seconds. Here we have total call duration for the last 5 seconds with green, for the last 30 seconds with yellow. Total call cost, average call cost, average call duration, and so on. We noticed that for stats, we have only one filter index in cache. That's because we had that configuration. Otherwise, if we wouldn't, I can stop this really quick, and I can. So if I comment this and then restart CGRates. And restart also OpenSIPS to be safe. Then I have to register again because we restarted the OpenSIPS. OpenSIPS. So now if you check the graph, we will see that start filter index entries will grow up, will continue growing and growing the more time passes. Let's see what's going on. 2 more minutes. Which one do you check?
Может там загрузить под макросы. Я линку тебе послал, загрузи там под макросы.
I probably messed up something in the configuration.
Missing a comma.
Yeah.
Right there. On your ops.
Oops. Sorry?
Well, if you look at the ops, a couple of lines up.
Yes. Okay. So restart CGRates.
Нужно под макрос.
Just so now I hope it's okay. Now it's growing. So the reason it's growing constantly is because every time we all the requests have an original, a unique origin ID. So we calculate, we check does a profile exist for this origin ID, and if it doesn't exist, we cache it as not found. So we do this again and again and again, and every request comes with its own unique ID. So it's constantly growing. And I had a bit more, but I didn't manage my time as I should have probably. So this is it.
Well, if we have people interested in getting the rest of the work, Silviu will be here, right?
Yeah.
So you can take the discussion in the room. Let's have some applauses for Silviu. And okay, we have time just for one quick, short questions, if we have any. Okay.
Yes.
If you look at your stats file,
At my stats file, okay. Yes.
you've got. Why is there 2 lines there for the 5
This
seconds?
is it can be only one line, but this is just for visual representation. We can it's cleaner. The first line represents the profile itself, and the second line represents the configuration of the metrics. So you can also do like one line for each ACT, TCT, and they also have their own filters and so on.
Okay, thank you. Thank you, Silviu, once again.
Thank
Great
you.
job. Next, we have Lorenzo. While he's hooking up, just a note, as in the previous days, we have the so-called coffee breaks. but today basically there is no official time allocated, so you just go out, grab whatever you want, come back and so on. So just to know that I think at 11 they will bring some snacks, coffee, anyhow it's all the time over there. So okay. All good, Lorenzo?
Yeah, just moving some stuff.
Yeah. So it's all yours from now.
Okay, thank you.
Thank you.
Big enough? Go for it. Okay, yeah, thanks for being here. Now we'll do first of all, how many of you are familiar with QUIC or RTP over QUIC in the first place? So this is QUIC or RTP over QUIC both? QUIC? Okay, and RTP over QUIC? Okay, yeah, so not that many people, that's good, because while I'll try to make, especially in the second part of the workshop, I'll try to provide some practical examples of how I started tinkering with all of this stuff and showing you some cool things that already work right now. I'll also do a brief introduction on QUIC itself, just so that you have a better understanding of what it is as a protocol and what it can do, especially with respect to real-time media. And I think we can skip this. You may recognize me from before, so I'll skip this one as well. Even though, I mean, some of you may know me as the main author of Janus, which again will come back during this presentation. But today I'll mostly focus on some things that I've been doing in another effort, which is an open source library called QUIC, which is a library that aims at implementing the QUIC stack, but also some of the upper layers, especially related to real-time media, because that's what I wanted to experiment with. And specifically, we will talk about RTP over QUIC today. And I may talk a bit fast today, and there's a lot of stuff to cram in. So in case you miss anything or you want to catch up on your own time, I also blogged about this a few days ago. So that's the link over there. It's a detailed description of the whole process, basically. So it goes into detail about what RTP over QUIC is. It shows the different demos that I'll also show today. It just talks about them. Here you'll see them in real time, but it's a good place to go back to in case you want to dig deeper and learn more. And of course, the first starting point is QUIC, because not everybody knows specifically what QUIC is and what you can do about it. And of course, it will be a very quick, pun intended, crash course about the protocol also, because I'm not strictly speaking a big expert on QUIC, so there's good chances that I may say something wrong. So in case there are some people that know QUIC better than me, don't throw stones at me for that. But basically, it all starts from, let's say, transport protocols in general, and we're all familiar with UDP and TCP. We know the pros and cons of both. We know why we use one for, let's say, media, why we prefer another one for signaling, or why we may use UDP for signaling as well. I mean, they both have their pros and cons and so on. And the main idea with QUIC was to try and get the best out of both protocols, because both protocols have strengths, but they also have weaknesses, of course. And so the QUIC was originally born as a way to transport HTTP3, so basically the next evolution of the HTTP protocol, which had long-standing issues like pipelining problems or head-of-line blocking and so on and so forth. So all the things that led from HTTP 1.1 to HTTP 2, the problems that HTTP 2 had, how do we solve them, how do we move to HTTP 3, and QUIC was the answer they came up with. And basically, even though of course it was originally meant as a transport for HTTP 3, it can really be used for everything, as we'll see. And most importantly, it looks like a transport protocol, but it really isn't a traditional transport protocol in the way that we know it, because UDP and TCP, you typically have them implemented in your kernel of your operating system or whatever it is, and you build on top of that. QUIC isn't, because QUIC actually is a transport protocol that sits on top of UDP, so it leverages UDP datagrams to exchange all the all the information. But while it sits on top of UDP, it borrows a lot of concepts from TCP and enhances them in order to build on top of that and make it better, let's say. And so it has all the features that you typically find in reliable protocols like congestion control, flow control, retransmissions, all that kind of stuff. And besides, compared to TCP, it also has built-in encryption. So QUIC is always mandated encryption when you use QUIC. So you cannot, you can use QUIC unencrypted if you use null certificates or something like this, but out of the box, QUIC is always encrypted, which means that, for instance, compared to TCP, you don't have to put another layer on top of that, like TLS, to provide encryption to the transport. QUIC is already encrypted, and most importantly, encryption also is part of the handshake of the connection itself, which also helps speed things up, because while we are connecting, we are also encrypting the channel, and so in theory we should get there faster rather than what we do with TCP, where we first have to do the three-way handshake and then we have to do the TLS handshake. There's a separation of layer that really isn't there with QUIC. And so it has interesting properties in that sense. And when we look at how QUIC works, typically in the standardization bodies, for each protocol, you typically have a single protocol describing how the protocol works. You can study that and then implement it. With QUIC, it's a bit more complex than that, because if you want to implement QUIC itself, you have to implement 4 different RFCs. Because QUIC has been designed since the very beginning to be, let's say, a protocol that can evolve. And so right now we are at version 1, they are already working on version 2, and so they have an RFC that says all versions have to comply to that. Then you have the specification for version 1, you have all the encryption stuff that I mentioned that is part of the protocol itself, separated in another document, even though it's part of the specification, just because of how complex it is. And congestion control is also in a separate document itself, which means that it's a bit complicated to figure out things, and it gets even more complex when you start building on top of QUIC, because HTTP3 has its own document, but it requires QPAC, which is another document as well. Then how you do datagram on top of QUIC, how you do web transport, and so on and so forth. But even though it is a complex protocol, there are a lot of implementations out there, because a lot of people were interested in all the cool things that you could build on top of that. A lot of different languages, there are bindings for a lot of different languages, so pretty much any language you're familiar or more comfortable with, you will find a QUIC library to do that, to use it. And when I first started learning about QUIC, because a couple of years ago I didn't even know what it looked like, I found this blog post over there really helpful, because they went very much in detail about learning really from scratch, presenting practical examples of how the protocol worked in practice. So I definitely abused those 2 blog posts a lot when I tried to implement a QUIC stack from scratch. Even though there were a lot of libraries available, I wanted to start implementing it from scratch, because that's how I learn. I was joking with Vasilios the other day about this is how we approach libraries, how we approach protocols. This is probably the hard way, but it's what works for us. And so I said, how hard can it be to write a QUIC stack? There's just 4 IRCs that I have to study. And of course, it was not easy at all, as you can imagine. So there's this joke over there where I'm basically just trying to figure out how the header protection works in QUIC because of the embedded encryption. Took me some time. Let's say it took me about a month to create something where I had a basic stack that could interact here and there, but eventually I got there, and it helped me a lot to understand the protocol. And again, I won't bother you too much with the details about QUIC itself, but there are some characteristics that I think are important to understand before we move forward, because they are important for the real-time aspects of QUIC, so whether or not we can actually use QUIC for real-time. And as I mentioned, QUIC does leverage UDP at its foundation, so it is founded on top of QUIC or UDP, and UDP does provide us low latency, as we know. And as far as the protocol is concerned, basically each UDP datagram can contain 1 or more QUIC packets. It's typically 1, but you can have more than 1 as well. And each QUIC packet has its own header, some more information and so on, but it's also made of QUIC frames. And the QUIC frames are what implement different aspects of the protocol. So I was mentioning, for instance, how you can do retransmissions on top of QUIC, which means that you need ways to acknowledge stuff. And acknowledgements, for instance, are specific QUIC frames that you can send. If you want to send data, you can send that as datagrams or streams. And both of these concepts are implemented via frames. You have frames to notify you about different kind of IDs. You have frames about everything, basically. So anytime you extend the QUIC protocol for something, you typically add a new frame that has some specific meaning in the QUIC protocol, which makes it very easy to extend. And an important part, of course, being implemented on top of UDP means that it's typically a protocol, even though it's a transport protocol and it is used as a transport protocol, it is a user space protocol, which means that even messing with it, updating it, experimenting with it becomes much easier because you don't have to wait for a kernel update to, let's say, check whether or not an announcement that you made on TCP is actually working or not. You can just update whatever library you have, experiment a lot. And this helps, for instance, also experiment a lot with different congestion protocols. It helps speed up things a lot in terms of working on the specification and things like this. And I mentioned how QUIC is always encrypted, which helps basically cut down on the setup times as well. An important aspect, and this will be clearer in an image that I show later, is related to stream multiplexing. And I'll get back to that in a minute because first, of course, congestion control, flow control is also a part of the QUIC protocol. And an important aspect of QUIC is that while with TCP and UDP, with TCP we identify connections via a tuple. Let's say we have source address and port, destination address and port, and the protocol name itself. In QUIC, that's not really the case, because even though QUIC has the concept of connection, because it is a reliable protocol, it sits on top of UDP, which means that things can be very, very fluid, and that's why they rely on the concept that is called connection ID instead. If the same connection ID is used in packets that come from different addresses or different ports, that's a packet that comes from the same connection, which means that it's very easy to implement stuff like connection migration or multipath or whatever. So it's a really flexible concept that could help, for instance, moving from Wi-Fi to 4G and vice versa, all while keeping the same connection alive and not having to reconnect stuff and stuff like this. But as I mentioned, one of the strongest points of QUIC is the concept of stream multiplexing, because we know that TCP implements a stream. So we have a stream of data over which we show everything that we want to send on the other side, and everything must be ordered, everything must be acknowledged and stuff like this, which works well, but of course it has the famous issue of head-of-line blocking. If I'm sending messages that are related to 3 different things on the same TCP connection and that packet number 2 gets lost, the recipient, even though maybe the recipient may have received all those packets 3, 4, 5, 6, and 7, the recipient will not be aware of them at an application layer until packet 2 is received, which means that that packet 2 over there is blocking everything else, even though semantically they may be different things, because it may be one message I'm sending to Razvan, one to Liviu, one to Bogdan. Maybe the message that I'm sending to Liviu is blocking the messages that I meant for everybody else as well. And with QUIC instead, there is the concept of stream multiplexing. So you still have the possibility to use streams, but you can create as many streams as you want on the same connection, and they are all independent of each other. And so each stream still has the concept of a stream, which means that each stream must be ordered and must be reliable and so on, which means that if I again lose packet 2 for any reason and I receive a frame with data related to that packet number 3 over there, the green stream over there, I will not be able to pass it to the application until all of those have been received, but the other streams can go on and can be sent and can be received without any problems at all. They are not blocking each other, they are only blocking themselves, which is an important property because, for instance, this is very much used within HTTP, because in that case, for instance, HTTP3, because each request can be its own stream, and so they are never blocking each other. It allows for effectively pipelining of different requests. getting different resources really at the same time rather than one request blocking the other and so on and so forth. But it can be very useful also for real-time media, as we'll see. And yeah, this is just a couple of words about HTTP. I mentioned how HTTP2 was plagued by head-of-line blocking while already being an enhancement to HTTP1, and so basically HTTP3 helped mapping those semantics to quick connections, like using different streams and so on. I will not delve too much into the details of this because it's not really relevant to the presentation, but you can dig deeper in that later if you want. But one important property that is really interesting is the concept of web transport, because while HTTP3 gives us access to traditional HTTP semantics on top of QUIC, like I can send a GET, I can send a response, I can get a response, and whatever, web transport is pretty much the equivalent of WebSockets to the world of QUIC. So exactly as in regular HTTP, you can escalate a connection to WebSockets, and so you basically take over that TCP connection and you start exchanging messages in a much more flexible way. Web transport is pretty much the same thing. So you use an HTTP connect to escalate that HTTP connection to a web transport connection. And once you get to web transport, you're basically, it's as close as possible to having access to raw QUIC as it is, with the advantage that you now have access to UDP and QUIC within a browser itself and dedicated APIs for that too. Which makes it very interesting because first of all it allows us to use UDP directly from a browser, which is not something that we give for granted. It's something that normally we can only do with VRTC and in a very constrained way. But it basically opens up to a lot of different interesting scenarios because we can send streams, but we can also send, again, datagrams. And I'll show a couple of demos about that in a second. And yeah, basically this is just an overview of how it looks like when you compare the two different approaches. Because web transport can be used on top of HTTP2 as well, and so on top of TCP as well. But of course it makes much more sense on top of QUIC, because of how you can use multiple streams at the same time in ways that don't compete with each other. Which gets us to the main point. So can we, now that we know a bit more about QUIC, can we actually use it for real-time media? And we can draw, let's say, a simple comparison between what we know, for instance, WebRTC, and what we partly know, which is QUIC. And of course, we all know that WebRTC can definitely use for real-time media because that's what it was conceived for. It is UDP-based. It was conceived for ultra-low latency because it was meant for conversational use cases. It is designed as a peer-to-peer protocol, but we often use a server in the middle, whether it is a proxy or as an SFU or whatever. So basically you see both of those scenarios a lot in the wild. And while it is not a reliable protocol in the strictest term, it does support retransmissions because you have ways to, for instance, detect losses and ask for retransmissions via TCP. It does have mechanisms for congestion control, bandwidth estimation, so that you adapt the bandwidth of your streams on the fly and so on. And of course it has a native support within browsers, which was the strong point of WebRTC. Basically browsers gave us a soft phone we could use for free without very little effort on our end. And with QUIC we can draw a little bit of a comparison, sometimes a bit far-fetched, but close enough, because of course it is more like TCP because we mentioned how it can be very much focused on streams, even though streams that are not blocking. But it is UDP based, which means that we have a window there to basically try and take advantage of some latency. Also because there is a way to send datagram frames, which are as close as possible to sending pure UDP on top of QUIC. Not really, because of course the MTU is smaller, because the QUIC does take a bit of overhead out of that UDP datagram, but close enough. It is always client-server, which is a big difference compared to WebRTC, but as we mentioned, we often use servers for WebRTC as well, so not that big of a difference anyway. There's retransmissions, multiple streams, congestion control, what we've already talked about in QUIC. And as we've seen with web transport, it means that we can also use it in browsers. So that's another strong point, because having access to stuff that you can use in a browser opens up to billions of devices that this could work on. with the big difference, which I think is a strong one, in that sense that with WebRTC everything is already made available to us very quickly. We have a media stack in the browser that we didn't have to implement. All the browser implementers implemented the media encoding, decoding, access to devices and whatever. With QUIC, it's much more on our own shoulders, which is both a pro and a con, because the pro is that we have much more freedom to do whatever we want. We are not constrained by RTP or other things. The con is, of course, that we have to do everything ourselves. We need to work on encoding ourselves using, for instance, web codecs. We have to implement all of those media protocols and the management of those protocols on our own. We have to figure out synchronizing media streams on our own, which can be very complex. But I mean, some people may actually prefer that because of the control it gives them. On the other hand, it is a lot of effort. Which eventually led me to start having a look at the existing options for doing real-time media on top of QUIC. Because of course I mentioned how everything started from HTTP3, but soon, especially in the IETF, people started thinking of different applications and use cases that you could build on top of QUIC just because of the different properties that it made available. And of course the first thing that came to mind, especially for real-time media, was we have RTP, we have been using it for ages, for VoIP, for VRTC and so on. Why not try and put that on top of QUIC and see how that works? And that's basically what that draft over there tried to do. And if you look at the draft, you'll notice a couple of things. First of all, that how to actually map RTP on top of QUIC is not that complex if you want, and we'll see a slide later that focuses a bit more on what happens on the wire in that respect. They cover more on, let's say, the mapping of the protocol semantics to the protocol itself, so to QUIC itself. So what are the things that QUIC, for instance, does that may make some of the things in the RTP and RTCP specification either redundant or useless or counterintuitive or something like that. Because, for instance, we mentioned how QUIC is encrypted by design, which means that do we really need, for instance, to use SRTP when we use QUIC? Probably not, unless we want to do something like end-to-end encryption or something like that, which simplifies things already. RTCP provides a lot of statistics, a lot of feedback that we use a lot in voice over IP and WebRTC, but do we need everything that RTCP typically provides? Because a lot of information there is related, for instance, to packet being lost or let's say round trip times or stuff like that, any kind of statistics that may be useful. And a lot of those stats are already provided by QUIC out of the box because everything is going on top of the same QUIC connection. QUIC connections can give us information about round trip times, about packets that have been lost, stuff like this. We have congestion control and stuff like that in QUIC as well, which means that we probably have some good estimate about the bandwidth that we have available as well, which means that all the effort that we may be doing right now in WebRTC on bandwidth estimation may, let's say, be less important than it is when used on top of UDP directly and so on. One thing that we know for sure is that when we use the stream capabilities of QUIC, we do need some framing. And of course, we all know that, for instance, when we put RTP on top of TCP, we cannot just put RTP packets on top of that and we're done. We need to properly frame them because it's a stream of data. And so we need to say, this RTP packet is this amount of bytes, because then otherwise we don't know how to separate different RTP packets that are coming one after the other, because RTP doesn't have any way to tell you how long the packet is. It just tells you, you just know whether you have a payload or not, but apart from this, you don't know much. And the fact that with QUIC you can send media and data, in different ways, it means that there is also different approaches that you can take with respect to multiplexing packets on top of QUIC. And this brings us to how do we transport RTP packets on the wire and how do we give them some meaning. And this is basically what this graph tries to summarize. Basically, the idea with RTP over QUIC is that, first of all, we can send RTP packets on QUIC in two different ways. We can use a datagram frame, which again is as close as possible to sending it on top of UDP. or we can use streams. So one or more streams where we can just show data as if it were a mini TCP connection on top of QUIC. And there are two key differences with those, even though what they do have in common is that within RTP over QUIC, you always tag RTP packets. And this is for a simple reason, that a QUIC connection, as we mentioned, can have a ton of different streams, which means that in theory, you're not forced to send a single RTP stream per connection. You could send 100 or 1,000 of RTP streams on the same connection, which means that one way or the other, you need to have a way to figure out to which context a specific RTP packet belongs to. For instance, if I'm sending my audio, my webcam, my screen, and something else, that may be 4 different RTP streams. And within the specification of RTP over QUIC, I need to know, as a recipient, to which context these RTP packets belong to. And this is implemented via the concept of a flow identifier. And this flow identifier is not really tied to any property of QUIC, so of RTP. So it is not tied to the SSRC, it is not tied to anything at all. You give that meaning, basically. So as long as you add a flow identifier to an RTP packet, you are telling the recipient this RTP packet belongs to this specific context. And so it could be flow ID number 3 may be Lorenzo's audio RTP stream, or all of Lorenzo's streams are going to be tagged with flow ID 3, and then you figure out if it's audio, video, or whatever via the SSRC or something like that. So it's basically just a way to tag an RTP packet and give it some meaning, some context, especially in a scenario where you have a lot of RTP packets going on the same connection. And so, whether you are using datagrams or streams, you are always having a flow identifier, with the difference that when you use datagram, each RTP packet fits in that datagram itself, and so you just add the flow identifier before each RTP packet. If you are using streams, you may be sending one or more RTP packets on a specific stream. And so what you do is, as soon as you open a new stream, you put the flow identifier at the very beginning of that stream, and all RTP packets that follow will share the same flow identifier, which helps you give some, let's say, it helps minimize the amount of information that you send all over, basically. And of course, as we mentioned, since stream is closer to TCP in terms of a concept, because it is a stream of data, we need to frame it, which means that we need to prefix each RTP packet with a length property so that we know how long that RTP packet is, so that if we are sending more than one packet over the same stream, then we know how to split them and separate them and know that they all share the same flow identifier over there. And you may be wondering which approach you should use. Should you put an RTP packet on a datagram? Should you put each RTP packet in its own stream so that they don't conflict with each other? Should you put more RTP packets on the same stream or all of them on the same stream? And there's really no single answer to all of that, because it really depends on the scenario and what you want to do. Because intuitively we may say let's put it all on a datagram because it's what we do with VoIP and VRTC. The problem being that a QUIC datagram is smaller than a UDP datagram, and so you risk encountering a smaller MTU than the actual MTU that you have available, and so you may not have enough room to send information there. A single RTP packet per stream sounds like a good idea, but it also means a bit more overhead of information, because we are replicating the same flow identifier over and over, we are creating a lot of streams. If we put multiple RTP packets on the same stream, we are creating a head-of-line block dependency for those packets, and so we may not want to send a complete session, a complete stream on top of a stream, but maybe it may make sense, for instance, for video to have all video frames that start from a specific keyframe to be the first to be a new stream. You have a new keyframe, you create a new stream, and then you put the keyframe there, and all the differences to that keyframe are on that stream. That may be a good approach, because in that case, if that that stream starts becoming sluggish and so on. The moment you receive another stream with the next keyframe, you can just forget about the previous stream and move on, let's say. So that may be also an interesting approach. But again, this is just to give you some ideas about how this could be used. The important part being this, that if we use multiple streams, they will not compete with each other, and so we will be able to send multiple RTP packets at the same time, and they will not depend on each other. We can just, it will work as close as possible to how we do with WebRTC and so on. And what could we use it for? I mean, in general, I'm wondering whether or not it could be the foundation for future VoIP, where maybe VoIP will start using QUIC for signaling as well, maybe for SIP. But I'm not really sure about that, because there have been a couple of efforts in the ITF to try and use QUIC for SIP as well, which would make sense, for instance, for the connection migration stuff. That would make a lot of things easier, and the always encrypted stuff and so on. But there hasn't been a lot of effort besides those attempts, mostly because the drafts that I'm aware of are deprecated. There are some discussions about how to use, how to negotiate RTP or QUIC sessions within the SDP. They have been sluggish as well. My personal opinion is that it will probably make more sense on a trunking aspect. So, especially because the fact that you can shove a lot of RTP sessions on the same connection means that maybe connecting to media servers and trunking them via a QUIC connection may make sense, because you still have a very low latency, but you have a dedicated connection just for exchanging those packets in a secure way, which is similar to an effort that you may remember from a few years ago, which was the real-time internet peering protocol, which basically tried to do the same thing, even though using HTTP3 rather than QUIC or web transport itself, but that's the main idea. And of course, the fact that it's still RTP means that it should, in theory, be easy enough to interoperate with WebRTC, especially from a trunking perspective. And so, which is basically what I'll try to show you in the demos in a few minutes. I mean, RTP over QUIC is interesting, but really most of the effort is being done on media over QUIC. We shall not focus on here. I mean, if you're interested in that, I'll actually make a presentation on that at ComCon in a month, which you should really go to. It's an amazing conference, and I'll focus exactly more in detail on MOC and its parallels to WebRTC as well. So it's time instead to start doing something more practical instead, and basically my efforts in that direction have been in a new library that I called IamQuick. And if you're curious about the name, and some may know about this joke already, IamQuick is a little of a pun about the fact that it says I am quick when you pronounce it, but actually the IAM also stands for Iron Maiden, which is my favorite band, and they had a song that was called Be Quick or Be Dead, and so that basically was a good match in that sense. I mean, I have friends that said that I lost the opportunity for a much cooler name for the library, but you can use it if you want. I don't want Nestlé's lawyers on my back anytime soon, so IamQuick is fine. And basically, as far as the library is concerned, it's of course an open source library. I mentioned how I started implementing my own QUIC stack from scratch, and that's what the library used up until maybe a month ago. When I talked about all this at FOSDEM a few months ago, it was still my own stack, but it had a lot of performance issues because, of course, QUIC is a very complex protocol. So I switched the foundation to one of the most popular libraries out there that is called QUIC, which is really tight and efficient. And basically the idea was to create a generic QUIC library, so something that you can build any sort of QUIC application on top of that you want, but with built-in support also for some of the media-related protocols as well, because that is what I care about personally. So when you build the library, you have access to QUIC functionality itself, but you also have RTP over QUIC and media over QUIC implemented as part of the library itself, which means that when you use those libraries, basically the QUIC aspects are hidden and you can just focus on the semantic of the higher level protocols instead, which helped me a lot, basically building test beds and experimenting a bit with those protocols. And the idea was to basically implement a few higher level APIs and in order to do more or less complex things. And of course, it's not really ready for production, mostly because none of those media protocols are not really used in production either. But it's good enough to make some tests and start tinkering with what may or may not be the future of real-time media, we don't know. And the idea is that it should be easy enough to install. I mean, it's just the usual dance that we all are familiar with. And the library also comes with a few examples, and a couple of them I'll show you in real time right now. And for instance, we could start seeing how it works with web transport, because I mentioned how web transport is the way that you use QUIC in a browser. So let's try and do this right now in a demo. Let's see if I can put this always on top. And I can start launching. This is just a basic echo server. So this is a QUIC server that also implements web transport that basically waits for clients to connect to it, and then whatever the client sends, they send it back using the same mechanism that they used originally. So for instance, I can put it a bit down here. I can use this web page. This is just a simple web page that I typically use because it implements web transport in a visual way. But of course, these are web transport are public APIs, so you can implement your own web application to do that. I can connect to my backend over there, and then I can start sending some messages. Like for instance, I can send a datagram. I can say hi. Datagram. The server will receive it and it will send it back as a datagram, and web transport will receive a datagram here saying all is good. I could do instead a stream using a bidirectional stream, because with QUIC we can use bidirectional streams and unidirectional streams depending on what we need. A bidirectional stream, as you can imagine, is a stream where you can both send and receive data. A unidirectional stream is where you just send or just receive data. So if I send a bidirectional stream, send it, I will receive it back as well, and it has also been closed, so it was a self-contained message in this sense. Of course, the bidirectional stream may last longer. If I try to send a unidirectional stream, as you can imagine, I will not receive anything back. I just sent a unidirectional stream, and of course the server said, I cannot send this back on the same stream because this was unidirectional. But these unidirectional streams are also something that we can use in a cooler way. Like for instance, let me see if I can send this message instead. Let's say that I open this again, but now I connect to a different backend. And for instance, I could send something like this as a unidirectional stream. Just a random JSON message that talks the Janus language. And I got something back as well. In this case, what I'm talking to was not the server that you saw over there, but was actually Janus. Basically, Janus was one of the first. I started integrating QUIC in Janus to see what I could do with it, and the first thing that I could do very simply was, since web transport is similar to WebSockets, let's see if I can control Janus via web transport as well. So use web transport as a way to control the Janus API, basically, which is what I did there. I just sent a message, if I can find my pointer. I just sent an info message to Janus, and Janus replied with all of the different details that this specific implementation provides. But of course, this is not really real-time media. I mean, it's a cool demo, but not really what we want to test. What we really want to do is, sorry, this one should go. sorry, I thought that was this is the slide. Sorry. I ended up in the very same place by mistake. So basically what we want to do is experiment more with RTP over QUIC itself. And as I mentioned, I started, RTP over QUIC is one of the protocols that I implemented within the library itself. And so when you use the RTP over QUIC functionality, you have dedicated APIs just for that. And I also implemented a couple of demos to prototype it, so I have a basic client that can basically receive RTP from a separate application like GStream or FFmpeg or something, and whatever it receives, it sends via RTP over QUIC and tags them with a specific flow identifier. And an RTP over QUIC server is just there to receive connections from clients, and whatever RTP packet it receives, it prints what it sees. So it prints, I received this RTP packet with this SSRC, this information and so on, and it was tagged with flow ID X, and it came over a datagram or a stream or something like that. So just something very simple. Something more interesting is the integration that I did in Janus. So basically to prototype a gateway in between RTP over QUIC and WebRTC. And if we check the demos over here, they are basically very simple, because if I take, let's see where it is. I can open the, let's first of all show how this could be done in practice. First of all, of course, we need to build I'll get to this in a second. So I can start an RTP over QUIC server here. Let's listen on port 9000 as before. Here I can start an RTP over QUIC client, and I'll feed it with GStream over here. So what we will do is, I started an RTP over QUIC server over there. I will have an RTP over QUIC client connect to that server, and then listen on two different ports for incoming RTP packets, and we're going to use flow ID 0 for audio and flow ID 1 for video, just to basically separate them that way. And so what happens is that we connect, we start sending stuff, and we see things basically. So we are receiving some packets. So again, this is cool, but not really that cool. I mean, we're not seeing anything interesting. We want to see something nicer, and so we may involve Janus. As I mentioned, I started tinkering with QUIC in Janus, starting with web transport, that I wanted to integrate QUIC as well, and this is something that is available in a dedicated branch. So if you go on the IMQuick branch of Janus, you will find these integrations and you can experiment with them yourself. And basically, I started from RTP over QUIC to WebRTC. So how I can get an incoming stream from RTP over QUIC and display it to WebRTC users instead. And the easiest way to do that was basically integrating it in the streaming plugin of Janus, because the streaming plugin in Janus normally does RTP to WebRTC. So it can receive RTP, normal RTP streams, and it can wrap them up into WebRTC streams that can be consumed by multiple users. And so it made sense to integrate RTP over QUIC there. And the way that I did it was basically I can, within the context of a streaming plugin, I can create one or more RTP over QUIC servers. For instance, in this case, I have this RTP over QUIC server called Test Rock. I'm listening on port 9000. I'm okay with QUIC web transport and so on. And then I can create a mount point that references that RTP over QUIC server, and I can say, I want to create a mount point that has an audio stream and a video stream, and all RTP packets that are tagged with flow 0, flow ID 0, they have to be treated as an audio stream that goes via WebRTC that way. RTP flow ID 1 means video, send it as a video stream that other way. That's basically the kind of mapping that I created between WebRTC, SDPM lines, and flow identifiers, basically. A very simple mapping, but it should work. And the idea is that once I start Janus and I create a RTP over QUIC server in that way, I can, as before, launch my RTP over QUIC client, connect to that port as we've seen before, which is the port that the integrated RTP over QUIC server is listening on. And then basically we can use different multiplexing strategies to send RTP packets. We'll see a bit how they differ. And then we can just, whatever we send via GStreamer to the RTP over QUIC client, we should be able to see via WebRTC as well through RTP over QUIC. So ideally we should see something like this. And basically what we do is, first of all, start Janus. Then we can open the streaming plugin demo and open the RTP over QUIC test. And of course, at the moment, we don't see anything because we are not feeding it anything. So there is no RTP over QUIC client and there is nothing sending data. And so what we can do is we start connecting the client, and I can see now here on Janus that a client is connected. I must be quick enough to feed RTP data, otherwise this client automatically disconnects. But I start a client over here, I start feeding it data, and now we should start seeing something. And because that's probably my bad. I actually started from the why we are not seeing anything, because I used datagram as a multiplexing approach. And as I mentioned, video frames are too big to fit in datagrams, which is why we saw something happening on that window over there. But we didn't see video because of actually RTP packets were not getting to Janus because the client was not able to pass video frames to Janus in the first place via RTP over QUIC. So what we can do is, for instance, using streams instead. And now magically we see something which, of course, just by fortunate accident is the Be Quick or Be Dead video by Iron Maiden. And so we are basically getting what GStreamer is sending via RTP over QUIC is getting to Janus, and we are now seeing it via WebRTC, which is cool. But we may want to do the other way around instead. So let's close this. What we may want to do is the other way around. So we may want to have WebRTC send stuff to RTP over QUIC instead. And for that, for instance, we may want to, first of all, start our RTP over QUIC server again. On a different port because 9000 is taken. Then we can open the video room plugin, which is our WebRTC ingestion point. We can connect. We can publish something, and then using an RTP over QUIC forwarder, on the web page. And by RTP over QUIC forwarder, I mean we open the video room demo, and we now ask the video room to send the RTP packets that it's getting via WebRTC to a specific RTP over QUIC server. So we're telling connect via RTP over QUIC to that address over there, which is the RTP over QUIC server that I just started, and then create this mapping for the IDs. So the audio streams in this case are mid-0. I add the tag of flow ID 0, for mid-1, send flow ID 1 instead. So let's see what happens. We start seeing all of these different frames being received by the RTP over QUIC server. And an interesting thing that you can see is that flow ID 0 is using datagram as multiplexing, and flow ID 1 is using stream. And this is a choice that the Janus plugin made on purpose, just because of what I just said. So for audio packets are small enough, we can fit them in a datagram. Video, not as much, we use streams for that instead. So basically just a simple way to do things. But an even cooler thing that we could do just before my time ends is WebRTC to RTP over QUIC to WebRTC to basically prototype that RTP over QUIC trunking that I was mentioning. So we have WebRTC on the edges, WebRTC sender, and a WebRTC receiver. But rather than having them connected directly with Janus, they are connecting via an RTP over QUIC trunk in this case, even though it's, let's say, an RTP over QUIC trunk within Janus itself. But this is the main concept. And what we can do is basically reuse the same demo that we are on. So I am already connected as connected here. We have an RTP over QUIC server within Janus, which is the streaming plugin. And so we can open it again. And so in theory, if I go here, and instead of sending stuff to that external RTP over QUIC server, or while we are doing that, because of course this RTP over QUIC server is still going, we can also send it to our own streaming mount point instead. Which means that as soon as we start receiving a keyframe, or let me see, yeah, we now have the video as well over here. So let me increase maybe the bandwidth a bit. And basically now we are indeed doing a WebRTC to WebRTC communication, but through an RTP over QUIC channel, which means that RTP over QUIC could indeed be used for trunking. Now this is for a very simple use case, but imagine it for, let's say, a big telephony setup where you have many servers interacting with each other. They need to have trunking capabilities, and that's something that could be used for that. And this is basically it. I mean, this is the demo that I did at home. I didn't have my beautiful cat Ruby with me this time, but if you got the point, we can at any point, of course, stop these things, because this basically matches the presentation that I made yesterday. Yesterday I talked about RTP forwarders. ROC forwarders are basically the same concept, but for RTP over QUIC instead, where you are externally sending WebRTC media via RTP over QUIC rather than plain RTP, but really the concept is the same. It opens the same capabilities. And I'm really done now, so of course there's some work to do. As I mentioned, it's not a complete effort, it's really a prototyping effort. But I really wanted to share this with you, mostly because this is public. I mean, there is a public repo that you can play with, so if this intrigued you, feel free to get in touch with me to chat about it, feel free to play with it. If you break it, which is likely, let me know and we can fix it together. But this is really it. And again, if you wanted to learn more or you missed anything, there's this blog post over there that you can refer to. And I don't know if there is any time for questions, but this is it. Thank you.
Thank you, Lorenzo. I think we have time for a quick question. Let's see. Okay,
I was very thorough. Okay, let's leave you.
And I was about to say, I thought you were crystal clear about this.
Hey Lorenzo, thank you for the presentation. So, with all your experience in dealing with this QUIC, where do you see it being deployed more? Like, is it more in the core network, or maybe between interconnects and that kind of stuff between operators, or at the edge, like what you're working on with browsers and all kinds of soft phones sending media over?
In general, QUIC itself is being, apart from real-time media, which is more of a novel approach where people are experimenting right now, it is actually used, you're probably using it right now without even knowing it, because basically, especially when you use Chrome or other browsers, they are often starting to use HTTP3 a lot. So you're not noticing any difference, because basically it's still HTTP and it works the same way and the content is the same, but they are starting to use it more and more for that. YouTube itself is starting to use QUIC a lot also for its YouTube streams and so on. So it is a protocol that is being extensively developed, extensively used. Cloudflare believes in it a lot, and of course Cloudflare is the biggest CDN in the world for web and more. So we are definitely going to see QUIC be used for more in general, and the big question mark is whether or not it will be good enough for real-time media. And I still have a couple of doubts on that, mostly because of the stream nature of streams. We will have to see. But for instance, for media over QUIC, which is probably going to be the most successful media usage on top of QUIC, rather than RTP over QUIC that I see confined to some specific things. For instance, media over QUIC, I see it much better suited for broadcasting, like for instance, you watch a football match in real time, you may not get the super low resolution, the super low latency, but you will have configurable latency, a lot of different things that you don't have with traditional streaming right now. So I think it will be used even more in the future, but we will have to see.
Thank you,
Do you have a question?
Yeah, no, just to comment on that is all the YouTube videos are running on QUIC.
Okay, yeah, because I assume that they are used if UDP is not blocked, of course, because one of the key aspects of QUIC, and it is related to some efforts in that direction, is that, of course, since it runs over UDP, if you are in a network that blocks UDP, you cannot use QUIC, for instance. And so in that case, you either fall back to TCP, or there are efforts to shove QUIC on top of TCP, basically, which is called QMAX. There is an effort in that direction, which is a completely different presentation, though. So, but again, thanks again for being here.
Thank you, Lorenzo. Okay, next we have Maksym Sobolyev. And he wants to try two new things today. One of them is keeping the presentation while actually typing directly from here, from his desk. He's very keen on doing it in the right developer approach.
Check. Good.
And the second new thing, he will actually talking about gaming, and how you can use Sippy for gaming. So yeah, that's something new, I would say.
All right.
Okay, so Max, it's all yours.
Thank you, Bogdan. Well, yes, and thanks everyone for coming for my second presentation. So today I'm going to talk a little bit about unusual topic, I would say. It will also cover some of my, early experience with computers and stuff. But there is this project that I've been kind of following for a long time. It's a game. It's basically a computer game. How many of you have not played computer games? Not played. You not play computer games?
I have MacBook.
Okay. All right. Well, it was a tricky question, obviously. But some of the motivation. So basically, to have some fun. Like we always do, serious stuff for work. But here I was basically just looking for some entertainment, I would say. And then I wanted to play with my kids, so needed something for that. But in general, Digger was originally created around 1983. It was a Canadian company, Windmill Software. It was released as a copy-protected floppy, and it was pretty popular at the time. I met at least several people who at least knew, of my age, who at least knew it. But my own experience with it started on a machine like this. It was a Soviet clone of PCXT. I don't have any pictures of the time, but it was in big design bureau. They did electronics and stuff for Soviet military, among other things. But as part of that electronic lab, they have one computer for the whole thing, which they were supposed to design probably circuits and run calculations, but in reality, mostly it was used to type text. And after hours, all people gathered and played video games. One of those games was actually Tiger, and I was like 12 or 13 at the time. I was just coming once in a while after school, and I was like, wow, those like big people, grown-ups playing games, and like it's really excited. They had a little competition, so they went in turns. So I was pretty intrigued. I did not get to play much at the time because I was like just kid, and it was only one computer, so there was quite a lot of contention. But anyway, a few years later, I found that this chap Andrew Jenner, he also likes the game apparently, and he went all the trouble. He disassembled the game. It was, as I said, it was binary for PCXT. Not only he disassembled it, he converted it by hand. There was no like IDA or what other tools, Hydra or anything at the time. So basically he went in and manually converted it, well, maybe with some scripts, but anyway, I think he wrote some blog posts about that, as it still might be online. So he converted it into C and put it on internet. So basically, I found it then, and I got very interested. So still remember the game. So I found it, and at the time I was it was around 2002. I was quite heavily involved, like with FreeBSD and Unixes. So I started tinkering and created like a port for it, so basically to run on FreeBSD console, so you can use it on FreeBSD. And around the same time, probably 2002, 2003, came out SDL port. So basically SDL was at version 1.0, and I also got quite interested. I also did submit some documentation patches, I believe, for some of the early SDL library. But anyway, so I took the SDL, took my, it was FreeBSD VGL library at the time, and ported it to SDL, put it online, and now I guess there is a site, so basically all this story is, and it's Sandro's site, and there is all like history. There is me mentioned about all this. And then nothing really happens for a few years. Eventually, like after a few years, came up WebAssembly. I got interested to try this technology. It was around 2012, 13. So I basically went in and ported. Turned out it had pretty good SDL support, so it did not take much time really. So I ported that, put it online, so now you can actually play it without installing, so everything just works. And then a few years later, I mean, it was probably around 2020, like came out machine learning, so it was a little bit of interest to put it on, to basically train the model. So here you see me trying to, I ported, there is like special libraries that you can use to interface your game. So that's me playing with bunch of instances running to train. It was quite an interesting experience. I learned quite a lot of how you train those models, how to scale them up. So yeah, that's the next step. Still have not finished it, but anyway, so this year I finally got into trying to make it actually multiplayer. So basically the game had Andrew was, when he was porting it from PCXT, he also added little multiplayer mode, but it required keyboard, so two people can play on the same keyboard, but they cannot go over network. So I started looking into it, and obviously LLMs are the thing now, so I got good help with good help of ChatGPT. I basically created the first version, which was just running over our raw UDP. So basically both control data and game data was over UDP, and the idea was pretty simple. So basically we have two players on two machines, and the game is pretty fully deterministic. So for each frame the game renders, we basically exchange controls. So one player sends his control, this guy says his control, they both receive the other side, and the game progresses. It works pretty okay, I mean, especially on the LAN with no packet loss. But we'll talk a little bit about that later. The tricky part comes obviously with the packet loss and all that handling. But it worked pretty well. So I implemented a little protocol to do controls and stuff. So basically it could synchronize like medium start of the game, tear down of the game. Few things came out initially. I could not achieve perfect synchronization. There was a little bit of difference in state. So basically you have divergence of your game on both sides, and then you need to basically debug and figure out why they don't reach the same kind of state after each frame. I can show how it looks. Yeah, so it looks like something like this. So you basically have games not fully in the same state. You have stuff on different sides in different places. But after a little bit of back and forth with ChatGPT and testing, all those was finally solved, and I got my first version, direct version working. But that obviously had quite big disadvantage, because in order to play between two players, you need to know both needs to know each other IP addresses, and you cannot play obviously over internet and stuff. So next thing I did, I started switching over to RTP. So as I said, first I started with just ad hoc protocol running over UDP, and it did, as I said, it did bring me results pretty quickly. But few things with custom protocols that I did not like. So it was difficult to debug. So if something did not work right, you will then end up doing a lot of head scratching, and even with logs, it would be quite difficult to find any issues. And then another thing that basically you don't get with the custom protocol, it's difficult to visualize. You might create some tools, but and so it was like, okay, let's switch to RTP. Even ChatGPT was initially skeptical, like, oh, why RTP? Why? It's like, oh, well, it kind of looks the same. And so after a little bit of persuasion, we did switch to RTP, and immediately it kind of improved observability and debuggability, because then after this, suddenly I could, for example, load it into Wireshark and see that the same packet gets transmitted zillion of times, for example. Or look for other anomalies and quickly iterate over fixing the protocol. It would also give me access to tools and visualization like that, where I could actually see the protocol in real time, so I could see what kind of delays I have and all that stuff. So yeah, that's kind of was the next step. I just switched to RTP, but I would still use custom protocol to negotiate. It was running over RTP, but kind of before the game. And so the next thing was to switch everything to SIP. So basically, the idea was to have SIP built into the game itself, so it could first use it to negotiate session parameters, so I don't have to put like port numbers and stuff. But also it would allow me to register to existing servers and perform basically play game over network. I looked into different alternatives. One of the alternatives I considered using our Python version of SIP stack, but the game itself is pretty tiny. So like if you don't link stuff statically, you only get like 300k executable. So putting the whole Python stuff would be pretty expensive in terms of overhead. So I picked our own library, which I created maybe like 5 or 6 years ago, specifically to address like running SIP on a small devices and in small setups. We call it microsippy, and it's on GitHub. You can find it there. But basically, what it is, it's as I said, very small but speed optimized SIP stack. So we basically optimized it so it can parse SIP messages very quickly and can run on very small amount of memory. We basically do a lot of specific optimizations to not allocate memory just willy-nilly. There is only a single allocation per message and stuff like this. It works very well actually. So I completed missed stuff. I only had parser, and eventually I got stuff running. So essentially now we have it in 2 modes. So the game could run either it could run through the SIP server, which could be pretty much any SIP compliant device, or one of the sides could be the server, and another side could be kind of the client. So if we are several people on the local network, I could run one instance, and everyone else could connect to my instance. And then I did a little experiment, which I have not really finished yet, but I tried to combine it with our Sippy B2BA, which is basically a SIP server, and also using built-in RTP proxy module with RTPO module. And it pretty much works, so it basically does not require anything specific, so I just give it some command parameters, and yeah, it basically works fine. Then a few issues, as I said, was with dealing with the packet loss. The problem there is, first I thought it would be easy, because how difficult it would be if we lost one packet. We'll just retransmit it and go on. But then when you start considering synchronizations between those 2 sides, you only have like 80 milliseconds between frames to do this stuff. So you need, first you don't want to do this recovery unnecessarily, so you don't want to send a lot of packets just to compensate for possible loss. But on this other side, you want to have pretty quick recovery, so game does not suffer. So eventually, after probably a few days of playing with the protocol, I think we figured out how to do it, and so that it seems to be working fine. So the only remaining thing that kind of not solved is make sure it can work over a longer duration. So right now we are limited to 80 milliseconds. Well, you can still play, but it will be slow. Yeah, and another thing that interesting thing that we found out is that we could also, even like without actually measuring specifically the delay, we could put stuff into each packet, and then it allows us to estimate a round trip. So basically, we could put few timestamps into each packet and derive pretty precisely how long does it take for the packet to propagate. Yeah, so that's pretty much it on like historical side and technical. So now I put just yesterday put some builds out. So maybe if you guys want, we can play a little bit online. Yeah, I will see how it works. I mean, we can play a few games, and then we might do a little competition of some sort. Yeah, let's see. Okay. So that's link to download. Let me start.
Alright, so who wants to join?
Where is he putting the executable on the Mac?
There is executable for the Mac. I tried it. You need to install SDL. If
Based on Linux?
yeah, I did put. Yeah, it's totally dangerous. That's a lot of stuff. Let's see. Could run probably. Capture. Capture. You want some instructions? Oh, Razvan?
I had to build it from scratch because I don't do it. Basically, it's not updating the.
So you got it started?
Yeah, it's starting. It can do some. For instance, I could hear
Oh yeah, you
some
can.
sounds and so on, but
Oh,
it's
yeah,
not
you can.
updating the UI.
Checking.
Okay.
What is
Oh
it?
yeah, yes.
So basically, this is just the background from the web page over here.
Yeah.
Kind of
I also try to
same, right?
minimize
So we
the-
start it and let's do it again.
Tech support.
Transparent and send bytes.
Okay,
Trying to
nothing
register.
is-
Trying to register.
But nothing is.
Same for me.
Okay, I guess.
Linux.
No, it's the STL that is not updating the content of the window. It's either stuck somewhere when it's not refreshed, because it needs to refresh the page every top frames.
What is the slash? It's trying to run it without any. Okay, it's not working. What are you using? Is it
This is
Valent?
No, this is it's X11.
Excellent. Okay, but at least it should work without. That's weird.
Oh, which is why I think it's really just an SDL rendering problem. Because I'm using OpenGL or the software rendering.
Should be automatic, like, yeah, you have display set up, and I could not even have it running without. frozen. Okay. Something to fix. Okay. Yeah, it kind of starts, but no.
The audio is there, but it's not rendering the content.
Yes. Okay. Well, okay. That unfortunately looks like we have. Does anyone have Windows any here? Probably not. But let's see if I can fix it on the spot. It actually works. X11, I tested it. It's funny, but not on Linux. On my FreeBSD machine, if I run it, it's totally fine. So that's the X11 version. I'm just thinking what. Yeah, while working with it, I did rework some of the graphics, so it kind of might have broken stuff. Oh yeah, I can try to have a quick build without.
If I run the Windows accessible with Wine, it works.
Okay, interesting. Okay, can you still register?
I said waiting for friends, so I don't know what's how I.
You gave it parameters. Right?
Yes, so you can just stop it here, just control C and then. Yeah, I passed the parameter, but you can also just.
Yeah, I'm just curious if you can ping my machine here. Let's try that. Yeah, it works. Okay. Yeah, that's good.
Yeah.
Just trying to ping. It's like. Oh yeah, this one.
It's a long history of playing Windows games on Linux, so Wine, I have to master it. So it's not letting me.
Yeah, might be firewall on my end. Just,
Oh, so it's not a failed, it's a filter.
yeah, give me a sec, I'll check. Maybe. That's why this dump could help.
So that's why it was not rendering anything, because the network connection was blocking and it was not
No, it's something else. I don't think it's related to the network, because our network runs in separate threads, so it should not block. It's probably something with ways screen is updated, maybe. Yeah, I said we did some refactoring just prior. Can you wait for a little while?
Oh, of course.
This is just okay. Let's see what with the network. Start capture. Can you run it again?
The wine version of the Linux version
Wine version. If you want.
with the address.
Yeah.
I see this one over here.
Yeah, it should get green when it registers, so I guess I'm not getting packets from you. Let's see. Yeah, that's what might be firewall. Let's see.
For wine.
Because I think the executable may be for Windows 64.
Okay. Can you try it again, Lorenzo?
Yeah, that depends also on if it is wine for 32 bits or 64 bits. Let's see, because
For you and alarm it was working.
yeah, but
Yeah,
let
still
me check.
filtered, yeah.
Yeah, let me check with I think I have the I have the 64 version of Linux with 64.
But it took
Because there are two different packages for 32-bit and 64-bit.
Anyone? No luck still? Okay, well,
It's just unmentioned.
yeah.
Yes, I have one.
Yeah, you can. Oh yeah. No, this is just the browser version. So it does not support network. So you can only play one player. Yeah, that's what.
You should be able to see it. Regardless of file about making sure the IP is Oh yeah. Okay.
Yeah, it might be blocked at the firewall somewhere.
Maybe they are not allowing connections between internal IPs from Wi-Fi.
Okay. Well, there is. We need a SIP server.
Yeah, on the internet.
Give me a second. You might have something. No. Let's see. Well, we can obviously run off. We have a server, but it's far away, so it won't be playable. We have a server which I use for testing, but that is in America, so this is going to be. Let's see. I'm just clicking. Well, I guess one way to do it.
but it's not connecting, right? It's not responding.
Yeah, bear with me. I'm trying to set up some backup. I think if we can still use our central server, I just need to disable, I guess, disable media proxy, and then if it should probably be able to go directly through the LAN. But let's see if this strategy works.
Like I installed Wine,
Uh-huh.
so with Wine,
Yeah, but it's not connecting to.
okay, so then let me
If
know.
you have SIP server locally.
Okay,
to
if this
try.
is useful, I'll let you finish.
Okay. So as I said, we tested with our SIP server, so there are two accounts. Let's see if I can disable just the media relaying part, and then we could probably try to use it instead of connecting to my Windows machine directly. Use media relay. Now let's test. So this is remote. Yeah, both sides registered. Let's see. But that is my office LAN. Let's see if they can play. If it works, we could replicate it here. Times to start.
seen lots of technologies come and go. A couple of people talked about older technologies. Bogdan opened up with some of the evolution. And actually David Duffett mentioned that free roll dial-up was coming back to life. That was actually my first time that I did some a VoIP call with a friend of mine. I was in New Jersey. He was in New York City. And we managed to use free world dial-up to do a little toll bypass. We made one call, it worked. It's like, okay, what are you gonna do? It's like, you know, we have our other things that we're doing. But that was a long time ago. And, you know, voice over IP, you know, was great back then, and I've never looked back. So what I'm gonna share is a little bit of what I've been doing lately. Yeah. Change is hard. People don't like change. It's been going on forever. I mean, the horse and buggies gave way to cars. I'm sure the people that were making buggies didn't like it. You know, today we've got AI, and you can, you know, accept it, you can embrace it, you can reject it, but it's here. And as I said, I've been in this game for a while, and we've, you know, I've seen technologies, and this is one that is going to stay. So it's a little disappointing when you bring up AI to people, and all they do is talk about, you know, hallucinations and how it doesn't do things right, and they seem to gloss over all the really cool shit that it does do, and the things that it does do really, really well. It's a child, and it's growing. And, you know, I think one of the most recent articles I saw, the quote, because I was going to use one of the Darwin quotes that Bogdan gave during his keynote, but I actually, a couple of weeks ago, I changed it to this one because we're all technology, we're all into this business. And I think you know who the gentleman at the bottom is. He's been, you know, he predates me in the computer industry, in data processing. And for him to make a statement saying, yeah, he's going to have to rethink his opinions on AI and what it can do and what it can't do, that kind of says it all to me. I have to agree. You know, certainly we all, you know, have seen the early parts of AI where somebody would get up and say, write me a poem in haiku. It's like, okay, that's cool, it got my interest. I was like, oh, that's neat. But then I started using it, and I started hearing people say, oh, it can write code. And I'm like, yeah, right, okay. What I'm going to talk about are some of the things that I've done with AI. I've been coding for a long time. I'm, you know, not the fastest, I'm not the slowest, you know, but I've been doing this for a while. I know, you know, I know how to write C code. You know, but I will say when I've started using these tools, my productivity has gone through the roof. Are there parts where it's slowed down? Absolutely. But by and large, on the whole, some of the really hard problems to solve have been able to be solved a lot faster and a lot quicker than AI. It doesn't make the syntax mistakes that I do. It doesn't forget to tab in Python. It doesn't forget a semicolon. You know, if it knows a language, if it knows what it's doing, it goes off and it does it, which is pretty amazing. So when I realized this was kind of really cool, one of the first things that I looked at were PRs and issues in GitHub for the OpenSIPS project. And I'm like, okay, is this AI any good? let me take one of these old PRs, you know, something that's multiple years old that people tried to resolve and it never got resolved. I'm like, okay, let me give it a shot. And so I turned it loose, and I got, honest to God, 5 minutes later, and I'm pushing it saying 5 minutes, less than 5 minutes later, I had a resolution. I had, yep, I see exactly where the problem is, and I'm like, yeah, right. And here's the fix. I'm like, yeah, right. And boom, you know, it's like, okay, I want you to run, well, that's my next slide. But anyway, that's just on the PRs and the patches. And then after I realized how good this can be and how, you know, and this is not a sales pitch, this is like how good some of this AI stuff can write code. I'm like, all right, let's write something new. So I had already worked before AI with Liviu on, and actually I think it was the last summit, I added some code to Redis, CacheDB Redis, to add some features to it. And one of the big features that was missing was clustering support. I'm like, okay, here's the good problem, because I know that, you know, Liviu and I had gone through the code, and, you know, we kind of knew what we needed to do, and it's just, you know, I have a day job, so it's not like I can focus all my time on it. So it kind of, you know, was a little bit backburnered. And so I'm like, okay, let me take this AI tool and throw it against that problem. I want you to take this code and add clustering to it. And I'm like, okay, you know, 5 minutes later, and again, I'm not exaggerating, you know, okay, maybe 4.5 minutes. It had a baseline of Redis clustering support for the CacheDB module. And I'm like, yeah, really? So now I'm testing it, and you know, it's one thing for the code to, you know, the tool to go off and write the code. It's another to validate that actually what it did is correct, because these tools are still young. These are not mature adult tools. They're like an intern that just got out of college or just got out of high school. They're good. But anyway, so I'm going to show off a little bit of that. Then I'm like, okay, during a couple of summits ago in Houston, I brought up Rust and how, and I'm sure you've all heard of Rust and how there's lots of value to it, and the learning curve for Rust is pretty steep. And I wanted to learn Rust, and I'm like, oh yeah, this is a steep learning curve. I have my day job, so I'm not, you know, spending, you know, all day long on it. And it was taking a while, and I got enough up that I could put a little demo together during the Houston summit, and you know, to just introduce it to the Rust, and you know, hey, OpenSIPS can kind of talk to Rust a little bit. And I'm like, wow, okay, so this tool put together some clustering support for Redis. I'm like, yeah, let me throw it at Rust, because it's like, okay, go create me some modules in Rust. I'm like, holy shit, like knock this stuff out, and it's like using shared memory. I'll show and demo a little bit of that later. One of the interesting pieces is that there's no C shims, and that was one of the key things. It's like, yeah, you can add, you know, a lot of the OpenSIPS modules, okay, all of the OpenSIPS modules require a little C shim to hook into the core. And I'm like, yeah, if I had Rust, you know, have a C shim and then Rust, it would be kind of more the same, nothing new. But the tool, the AI tools, were able to put together Rust modules without a C shim. I mean, just using the FFI, if you speak Rust at all, the foreign function interfaces are able to connect and talk right to OpenSIPS. And I'm like, wow, that's kind of cool. I've not committed some of this code yet because, you know, it's brand new. OpenSIPS 4.0, 4.x is on its way out. So, you know, I kind of like to get that stabilized and then actually have a longer discussion with the core developers to see if this is a direction they want to go. But that is something else that, you know, I'll show a little bit and try to demo. You know how live demos go. So after I was blown away with, you know, bug fixes and then clustering for for Redis. And the Rust module, I'm like, man, let's keep going. So one of the other technologies that I had only just scratched the surface with is NATS. I don't know if anyone here is familiar with NATS, but it was interesting during Livyu's talk about the clustering of OpenSIPS, servers. If you've got multiple locations and clusters, if you OpenSIPS servers here and here and here, and they're all trying to talk to each other in a star topology, you kind of have a lot of links. And he showed a picture of just a bridge, a single link between locations. And I'm like, that's exactly what NATS does with its clustering. So NATS is a key value store. It's got some streaming going on and some other kind of really cool features. So I'm like, okay, AI tool, go try to build me an OpenSIPS NATS module. And lo and behold, I got it. And I'll be showing that a little bit later. Then that was really my talk. And then I'm like, I'm still I'm into this. So it's like, okay, what can I do? What kind of a stretch goal can I have? And it's like, can I really pull all this stuff together and actually get some AI working? Because people talk about prompts and prompt injection and TTS, text to speech, and ASR, automatic speech recognition, and all kinds of cool, interesting things. And I'm like, wow, can I have a stretch goal to actually get that to work? And we'll see. We'll see if the demo works. So that's kind of the roadmap. That's what I'm going to talk about. But first things first. As I said, I started off looking at PRs, and probably, not say probably, perhaps many of you or people on your teams or companies will be using AI to help solve problems. Flavio, is he here? Flavio was here talking about how he's ingesting all this data and having the AI tools say, oh, we're having problems with a call, know that there's a problem before the customer does. And I'm like, okay, cool. Well, I've got tech support folks. I have the NOC calling me saying, we've got audio problems. What do we do? And I'm like, okay, send me the PCAPs, send me the call traces. Well, the PCAPs actually send me the RTP because if you're capturing RTP, you can have that. You've got your PCAPs, you've got your logs from OpenSIPS or what other services you're using, and I would give that all to the AI tool, and boom, it's going to give you exactly where the problem is. It will also, it can also provide recommendations as to how to fix it. So what I heard a lot of over the last couple of days was, yeah, these tools can help detect problems. That detecting is a huge thing, don't get me wrong. But you've got to fix these problems. And now, one of the things I did was I took a PCAP from our NOC, and they sent it to me, and I'm opening it up, and I put it into the AI tool, and I also fired up Wireshark, and was like, okay, let me dig into the PCAP. And by the time I had the thing loaded in Wireshark, where I could, okay, let me look at the VoIP calls, and let me see what's going on in the flows, what doesn't look right here, the freaking AI tool already had the answer. And I'm like, really? So it's not even that I can't code that fast, I can't open up Wireshark that quickly, but that's the value, is if you can get these tools to work for you and to be your intern, it's huge. As I said, I did a fair amount of code development with the tools, and I've kind of, landed on this kind of a flow where the tool's got to diagnose the problem, or diagnose, what you're asking of it, provide a solution, which you say, hey, give me a solution. They may be right, they may be wrong, but they're going to give you a solution. Then implement the code. So that's, again, it'll go through the logic of the routines, and it will implement code. And then one of the things, you know, just like, and as I said, I showed you earlier, I've been doing this for a long time. I know I have to document. I don't document as much as I should. I know I have to test. I don't test as much as I should. Hey, being honest, I don't know how many of you here are in the same boat, but testing is one of the ways that I validate that the tool actually did what I asked it to do. I'm going to say, recreate the crash, recreate the seg fault. You know, don't come back to me until you have found a way to recreate the seg fault that the core dump has. And, you know, it'll crunch, and it's not going to be a 5-minute thing, but guess what? It'll come back and say, you know, 9 times out of 10, yes, I've recreated the seg fault. I'm like, cool, now fix it. And it'll go and say, yep, I've got it fixed. And after it says, you know, that it's done something, and if you've used these AI tools, you'll know that they're very positive. Maybe from a psychological standpoint, they're always very, I know what I'm doing, I know I'm right, this is the answer, you know. I kind of take that with a grain of salt, because I don't always believe it, and half the time it's lying to you. And so, what I'll say is I want you to run tests. I want you to run 30,000 tests. I don't care how you do it. You know, here, use Sippy, you know, create a UAC, create a UAS. I don't care how you do it. I want to see 30,000 tests or X number of tests. And I want you to test edge cases. And I want you to, you know, make sure the problem happens with your tests. And then I want you to implement the fix. And I want you to make sure the problem has been resolved. And if it can recreate the problem with its own tests, and then have the problem fixed after it's implemented its code, you know, I'm more or less going to say that's pretty good in my book. It's not like it could ask a human being to do any better, you know. And if it doesn't fix the problem, it's like go back and keep doing it. You know, I know that's this is like computer programming or computer engineering 101. These 5 steps. This is nothing new. But if you mandate, if you tell your tool, this AI tool, whichever one you're using, to at least follow something like this, I think you'll have good results. I have. The testing I got, you know, below implementation. If you're into test-driven development, maybe you write the tests first. You tell the tool, I want you to write the tests, and then I want you to implement the solution. It's, you know, that could work too. I think, again, it's a little disappointing that some people are so adamant and have this bad impression of AI. It's like, oh, I don't like AI, and it's like, really, you know, the AI doesn't write good code. You know, human beings don't write good code. I write bugs every day. When I'm writing code, I never write code well the first time. I have to iterate multiple times before it becomes, you know, before it gets better, you know. Look at the bug reports on GitHub, not just OpenSIPS. Pick any project on GitHub. You know, look at the bug reports, look at the PRs. Human beings are not writing good code. So any kind of a tool that can help, I think, is incredibly valuable. Here are a couple of the PRs that I'm talking about. So it's like, okay, Norm talked about this stuff. Like, what did he actually, you know, did he really? Yeah, just go to the OpenSIPS, you know, PRs and look at Norm or whatever, and you'll find a couple. A couple of the interesting ones that was really bugging me had to do is this TLS OpenSSL seg fault, and that was really tricky. And even the fix for it was like pretty complex. And remember, I started talking about, you know, CacheDB Redis, and I'm like, you know, I remember a security guy coming to me, you know, years ago saying security is like an M&M. It's got, you know, a hard shell. A company's security has a hard shell on the outside. Once you get in, it's all gooey on the inside. Meaning, you know, once you're inside the network, there's really no security. So if you've got a Redis cluster or a Valkey cluster, we'll get to that in a second. Inside your network, you can certainly connect to it, you know, in clear text. I mean, hey, it's my internal network, nobody's gonna get in. But I'm like, okay, that's cool, but I kind of wanted to use TLS. I kind of wanted to encrypt my traffic to these services, even though they're inside the corporate shell. Well, that was not happening because of this segfault. And it was like a pain. I'm like, okay, I won't use TLS. And so that was like something that had irked me for a while. And using these tools, was able to get to the bottom of this. Now, 4.0 has redone TLS, and this patch I think is not needed for 4.x, but up until 4.x it kind of is. And I think I spoke to Silviu, and he was talking about backporting it, which would be cool. The other one that was kind of interesting is I was doing some testing with Janus, and I got this message saying something about, like reassembly of packets is not implemented or not supported. Like, really, this is OpenSIPS. How can it not implement something? I was like, what's going on? So I dug into it a little deeper, and then I turned the tool loose. I turned AI loose on it, and I said, you know what? It's a perfect example of a user, an OpenSIPS user that wanted this feature, but it raised a ticket saying, it's not implemented, and it was somewhere on the list of future feature development for OpenSIPS, somewhere on the pipeline. So I'm like, oh, maybe I can help out. Lo and behold, 15 minutes later, maybe not 15 minutes, but lo and behold, there's now support for WebSocket fragment reassembly in OpenSIPS. And some of these have already, most of them I think have been merged. There might be a couple that aren't merged yet, but that was huge. So not only are these AI tools able to help solve bugs, add new features, but they can actually implement some RFCs, which is kind of nice. So as I said, these are just a couple of the things, PRs that I've added. The one at the bottom I haven't pushed yet. There's a bit of what I'm going to show you I haven't pushed yet. Just I'm busy. My day job is got a lot of my time, and so some of this is it's new development, and the OpenSIPS guys have been busy with 4.x, and so I didn't want to burden them with all this extra stuff because I've been like on fire. So that's the RTP engine, subscribe and publish PR. There is some, I think there is a little bit of subscribe and publish, but this adds a little bit, it adds a new command. Okay. All right. So, hopefully, some of this will work. All right, so Valkey, if you're not familiar with Valkey, okay, if you're familiar with Redis, Redis, key value store, okay, everybody knows what Redis is, I guess. I guess their licensing changed recently, and a fork of Redis called Valkey was created that has a little bit more open licensing. Okay, they're supposed to be drop-in replacements, and from what I found, they are, for good or bad. And so the updates, the Redis updates, also apply to Valkey, and I just decided in my demo to use Valkey instead of Redis, but they're basically the same animal. Let's see. These are a couple of PRs. You don't need to read that. And then we're going to see if the demo works. This is something else that's brand new for me, is using my slides or slide dev. So I'm using that because you can have API calls right from your slides. So some of this should be real time using API calls to OpenSIPS. I'm going to see if it works. So I'm going to try to publish a couple of messages. There we go. So we have a call. You see on the, there's one key. These will time out, so things will happen and not happen. Some of the support for Redis clustering or VoIP clustering. I'm going to reshard. I'm going to try to reshard. And it looks like it worked. Although it does look like one of the nodes crashed. That's all. Hey, it's a demo. I'm going to add another node. We'll see if this works. Oh, and this is all going through OpenSIPS. None of this is like directly to VoIP. This is everything is going through OpenSIPS, and I'm just logging the new cluster code that I added allows these commands, and you'll see. I'll show some of the config and the MI commands in a second. So we added a fourth node, and now we're going to hopefully reshard some keys onto that fourth node. Hopefully. Come on. It does work. You have to believe me. Well, you don't have to believe me, but. Well, it does show I got node 4 up. And I'm trying to send some more keys out to it. Hey, it's a demo. All right, so that doesn't want to work. And we have an MI error, wonderful. Well, these were MI commands, so these were new commands. So the idea is I should be able to reshard the nodes, delete a node, which I have tested, and then add it back in, and the topology is dynamically refresh. The config is just like what you would expect. The config really hasn't changed. There might be some new parameters, but there are some MI parameters that show the cluster. It'll show the cluster. The MI commands return JSON, so you can see that there are clusters. The cluster is there. And there's, yeah, some, it's not happy. I'm getting some MI errors for some reason. That kind of sucks being early on in the presentation. I hope this doesn't continue. But you can see some of these different services are reachable. And the keys, oh, hang on, maybe I can push some more keys and see if this will dynamically change. Uh-oh, this is not gonna bode well for the rest of the demo, I think. probably will just move on. We might move on. Well, I was just saying how great everything was, and my presentation is locked up. Oh, that's... Okay, well, that's no good because the screen that won't show up is are the Rust modules. Oh, you got it there. Oh, great, but I can see nothing on my screen. Okay. These are the Rust modules that I've added, and they start with there's a core which controls some of the caching, some of the foreign function interface connections. And you can see that there's, what are they, 5 modules underneath it. Some of them do similar things that OpenSIPS does today. For example, the concurrent calls. The SST, the SIP session timers, is one module that I know has not been maintained well, has got a lot of bugs in it. So I thought that was a really good module to try to convert to Rust to see if we can't maybe update the SST module, the SIP session timers. One thing that also I thought would be interesting would be adding webhooks and the refer handler at the bottom. And the reason I'm not, wow, I don't think you can demo anything. The refer handler was because the only way that OpenSIPS can handle refers right now is using the back-to-back user agent module. And that's cool, and it works, and hey, I use it. But the B2B UA module does not currently play very nicely with the dialog module. So if you want to use dialogues, you can't really use the B2B UA module, and sometimes you want to. So I thought that and really the only reason that I don't say the only reason, one of the reasons for using the B2B UA module is for the refer handling. And so I thought I would add a Rust module to provide the refer handling. Now I suppose we could also do this in C, so you don't actually need Rust, but this was a good example to do. So, wow, and see, I don't have the, sadly my demo is broken. I can't click the live button to do the live demo or to show live MI commands. Well, that's what happens when you do a live demo. Let's see. Okay, as an example, in OpenSIPS prior to, say, having this particular Rust module, the way you could maintain state would be, to use the local cache, which is cool. But the nice thing, and one of the things I wanted to show off, and I haven't pushed these up to the public repo yet, but I will, is that you could use shared memory with these modules so that Rust could maintain state. Something like concurrent calls. That would be a perfect use of maintaining state. Yes, that's only good for a single OpenSIPS instance. If you've got a cluster, you're still going to want to use something external like, Redis or the new NATS module. This really is terrible. I don't have any live demos. I apologize. I then added a series of NATS modules. There's following the same kind of idea, there's some common code, and the common code goes into this libnats. But there's to follow the way that most of the other OpenSIPS modules are configured, there's an events nats and a cache DB and a consumer. The events is kind of nice because it does expose the event interface. If you've ever used that in OpenSIPS. One of the nice things is I set up a watcher so that if a key changes, an event will get triggered. So if you're watching a particular key or a set of keys in NATS, and that key changes, an event will get triggered, and you can then perform some script operation on it, on that fact. Yes, I see the red up in the left corner. Don't have to remind me. So boy, I'm really sorry because these are really, it's really interesting, some of the demos. So as I said, you can subscribe, you can watch to see when keys change. So these are the, boy, this was going to be the demo that's definitely not going to work. And I had my speaker, I had everything ready to go. We've got OpenSIPS, we have the new NATS modules. I added this publish subscribe to RTP engine, a little bit of an asterisk for the demo. And what I was able to do is, well, I'll explain it, even though I can't actually demo it, yes, at least we have some static diagrams. So this is how NATS fits into the picture, and everyone should be, or most people probably should kind of get it. I then added this media forker because what I wanted to do is I wanted to have a call from Zoiber from my laptop, like a normal call between two endpoints, and have the media forked, kind of like SIPREC. And I thought about using SIPREC, but then it's like, hey, let's just do something new, because what I wanted to do in this media forker is also do the ASR and the TTS, and take that and have the pieces pushed down, published to NATS. And it is all working, and actually, hang on a second. I'm seeing, I'm not gonna risk it just yet. Yes, so you can see there's an RTP engine publish. One of the reason I added the PR for the RTP engine publish and subscribe was to be able to do just this function. Is RTP engine is able to fork streams. You can subscribe to a stream and you can publish to it. And OpenSIPS didn't have it exposed in a way that I could use it from the script. So that's why I added that function, and now it was able to be exposed. So now you can fork your media without using SIPREC or some other external asterisk free switch, whatever. And then what I had working, and it's been, of course, this is like Dan's demo. It's like it was working 5 minutes ago. I was able to take the media, have it speech to text, have the text sent to matrix. If you're not familiar with matrix, it's like, okay, Slack, matrix. So I was looking for, kind of a free tool, an open source tool, and I, said, oh, I could use Matrix for this. And lo and behold, I was able to have Matrix write a little program to listen to the NATS key value store and then write the text from my speech into a Matrix room. And that was all, like I said, it was working 5 minutes ago. And then I was also able to write text into Matrix and have it translated to audio and then played out on the Bluetooth speaker that still might work. But again, these are the components, the tools, and I am going to, as I said, the AI. This is what was sitting, in that media fork animal. Are these tools? And I am actually going to see if things booted back up or whatever. Oh, here's the last slide. So this entire presentation, even the broken part, and all of that speech to text and text to speech is running on this NVIDIA Jetson Thor that's sitting right over there. There is no cloud, there's no API keys, there's no cost, there's no internet, and the brokenness of the demo was not the Thor box, it was something else. I mean, it's running a lot of stuff. As you can see, it's running 37 containers, and it's, that box has got, I think, 14 cores. It's got 14 cores and a Blackwell CPU, Blackwell GPU. So that was like the really interesting part of the demo, and I'm gonna actually see if I can make it work. We'll see if it actually connects. Oh man, I'm gonna have to. Okay, that second tone said. Oh, come on. Here we go. All right, those were some of my test calls. As I said, this was working 5 minutes ago. I'm going to come over here to, I'm not sure which side the speaker's on, so we'll try that. I can do this, and I can try. Actually, yeah, I'm going to try to make a phone call. All right, I don't know if you could hear that. So it was playing. Anyway, this was all going through that box, doing everything I just showed you. I don't know what it's playing. Oh, it's taking what I'm saying and translating it?
Yes. In French.
All right, so. Try to get the volume up on this.
OpenSIPS Summit?
Well, it did the TTS, it's not actually talking to me now.
Parlez à moi maintenant. Oh Ben, ça fait le TTS. Ce n'est pas vraiment.
Traduzione in italiano in corso.
That was Romanian.
Quello era Romero Bub.
I think it was Italian.
Oh, that was Italian?
Italian.
Oh, that was Italian.
Oh,
Oh,
quella
yeah,
era italiana.
it was Italian.
Oh, quella era italiana. Oh sì.
There you go.
Traduzione in italiano in corso. Ecco qua. Là, ecco.
I think that was Romanian.
Penso che fosse Romero.
No, maybe. Well, sorry, it's having some problem, but the mic drop moment was being able to be in Zoiper and be on a call speaking English and then having it translate to a different language in real time or near real time. It's kind of there, it's working, except the demo is broken, but you could hear the text out. All I did was start a call with Zoiper, and you could hear actually when I was speaking, it was probably coming in through my Zoiper, my laptop mic, and then coming out the Bluetooth speaker. Yeah.
The main problem here with the translation is the other type of the languages, because we're having also this. Because, for example, if you're translating to Japanese or something like this, you need to listen to the end of the sentence, because you cannot do a real live translation, because the translation is sort of fixing itself.
That's exactly the problem. So traditionally, the way you would do these translations would be you would take your speech, turn it to text, then in English, let's say, then take the English text, turn it to French text, and then take the French text and turn it back into French spoken audio. And that's like, okay, that's like year one of doing it, but year two is S to ST, speech to speech translation in one step. This is brand new. This is new tech, so I'm sure it's not working great. But the idea that I was trying to demo is that you could have English speech come out and have it translated into a different language in, more or less real time-ish. That was supposed to be the mic drop moment, but it wasn't. Yes?
Why did you decide to implement the Redis cluster instead of Redis managed by Sentinel?
Because there was no clustering, so that was one thing. I guess that was one way of adding, easier way of adding Redis clustering to OpenSIPS than adding a Sentinel. I'm not a big fan of Redis, and I'll tell you why, is because to get HA, you really need, at a minimum, 6 Redises. So you'd have like 3 Redis servers, and then 3 behind them. For, true HA, that's 6 servers. With NATS, you don't really need that. So that was, but I hadn't looked too much into the Sentinel, using the Sentinel instead of just regular clustering.
Basically, just the cluster distributes your key on this key slots, and then for each key slot you have kind of single master and everything else replicas. And you should implement routing. Like if you want to update this specific key, you should go to this server and update as well, like some routing protocol. But with Redis Sentinel, you just have quorum and dynamic master, so like key spaces, a single key slot.
Yeah, that's a great idea. That's why they got Sentinels, to be able to do, Redis Sentinel, to be able to do, create an implementation like that. I'm actually, personally, I'm kind of moving away from Redis and Valkey toward NATS. I like what I see with NATS. It's lightweight. It's got lots of really interesting things, and it does support TLS and encrypted connections. But yes, good point. Questions? No one liked the translation?
I'm still a bit concerned about the speech-to-speech because it's not solving the problem like the original problem in the sense that you have one sentence and it's classic example again with the Japanese. The order of the words, they are mostly backwards comparing, for example, to English. So you cannot even start translating correctly. So it's not a problem like speech-to-speech or speech-to-text.
Isn't the solution to that using these tools, using smarter models?
I don't know, but at the end you will always have this type of delay, of one sentence, no matter what. You cannot have real time.
Right.
So
to be fair, we have that same problem with the line interpreter.
Yes, but how it seems like the live interpreter are working before, on the official venues and stuff, they have a sort of speech beforehand. So it's not always live. Sometimes it's really
a script. They have a script.
Sort of, at least some.
If you're doing live interpreter.
If they're having some sort of combination between the script and between what they are hearing, because sometimes speaker can be a bit derived from the script, but it's more or less the same idea.
I think this is relatively new technology, so these are definitely problems to solve, and you're 100% right.
It's not a problem. You cannot solve this problem in a sense because it's like the structure of the language. You cannot solve it.
Yeah. The context is important, and you don't always get the context of the sentence until the end.
Yeah.
Oh, then you can't translate it until the end.
Yes. That's the thing. Because the last word in the Japanese sentence can change, for example, the meaning.
Oh, and it may take you a few seconds to get there.
Yeah.
To know that the beginning. Yeah. So
it's like a
jitterbug.
solve.
Yes.
I'm sorry.
In German, also the same.
Oh, in German, it's also the same.
Last word can change the meaning.
Oh, great.
And the effect of that is when you're doing the translation, if you're doing it live as the words are pronounced, then you might actually replace some of the words that were used earlier because of a different meaning.
Yeah.
So you got to go back to the beginning, replace the words used to get the correct meaning that you only got from the context at the end of the sentence.
These are really important concepts that have to be solved. There are problems that have to be solved. Some of it is with the speech to text, just writing out the text, and it goes back and it'll correct. It's like, okay, so it thought the middle word, this word was something, but as it gets more context, it corrects itself. Sounds like a very difficult problem. It's much easier code software that I was talking about early on in the talk. That's easy, because it's very, it's very deterministic.
The extra problem that you have to deal with on top of that is the dialect or variant of the language that is spoken, because Puerto Rican Spanish, Mexican Spanish, and plain Spanish are different. They have differences in the usage of certain words with different meaning as languages evolve over time, as as that happens. So you can't do the word-for-word translation of those as well, and you don't know which version of Spanish is being spoken.
So how do you
That is a very good question.
How do you codify that? Put that in software.
Yeah, that's a very good question.
I mean, these are great topics. I don't have an answer for it. Use a lot. There you go. There's your question.
Even Americans use the same word as UK English people do, but they mean slightly different things. Yep.
Yes.
So
I guess there'll be some technologies in some areas where a live interpreter is really the way to go, rather than trying to hack together some sort of a text to Spanish or text to German.
Yeah, we have some which are medically trained, so that they won't misunderstand the simple thing.
Yeah. And also a question like, can you, I was, like some years ago there was a project, some Kickstarter or whatever, having sort of like phone-sized device that will be working fully offline, but this kind of like live translation, more or less. So can this model can be fit, so how it could be the minimum hardware that they can run on for the moment?
Well, one of the
I've seen this one.
One of the conferences that I go to annually is CES in Vegas, and that's where they've got a lot of this new tech. And they've got these little earbuds that will translate from, you know, X number of different languages. But I don't know how they solve these problems that you're bringing up.
They not.
I mean, yeah, they've got a little thing. Oh yeah, here it's like got 83 different languages put in a year. I'm like, really? You know,
But I think it's usually something connected to the phone, which is connected to the internet. So.
right? But I mean,
the challenge is these earbuds, they'll translate. But if you go live on it, then that's very cool.
as you said, from a medical standpoint, you don't want there to be any you don't want to be any mess up ambiguities. Yes.
I don't know if anyone remembers the universal translator from Star Trek.
Yes.
It usually waited for a bit to like gather a database of that particular language, run some scanning and profiling, and only after that it would be used. This is like to answer the question of what dialect is being used live, what language is being used live. So I think even they anticipated that there is a back connection point before that. And even if you use a live person translator, even they would wait for a bit for that communication to end. Let's give the example of English to Japanese or vice versa. Like even a live person translator would wait for the communication to end to gather the whole meaning and then translate it. So I don't think even like a person would say, yeah, I'm translating word for word.
So waiting for it to end is great, and this is good, I guess, for an offline kind of an application. But if I'm making a phone call to someone who doesn't speak English, I kind of want it in real time.
You cannot.
I don't know how you do it.
It's just you cannot. I just found, let's say, this reference. So in Japanese, for example, the verb will go in the end of the sentence. So I will go to the theater. You will have I theater too, and only at the end you will go there and not run and not crawl there. So, but speaking English, you will I go like it's the second it's subject, verb, object.
So
when you have a different structure, you cannot.
So in telephony, which that's why we're here doing this, is telephony is real RTC, real time communication. How do we make it real time?
Time travel.
At the end of the day.
I'm sorry?
The machines, as soon as the AI continues to advance, a lot of the phrases you're going to be able to use little tips and hints and predicted text to be able to put that in the phrase. And also we're very, very linear at the moment in terms of this is the text in, this is the text out. In terms of if something goes wrong in the future, I anticipate as soon as the AI gets better, it'll be able to stop midway word, it'll be able to stumble, it'll be able to correct itself. So even if it thinks I'm going to go in this direction, then that wasn't what the end of the that wasn't the verb at the end. It's going to just be able to quickly correct itself, and it's just inevitable.
So maybe that's what it was. It will eventually these models will get trained on all the different dialects, I guess.
The context of a conversation is what you're looking for. That's how you can effectively roughly predict what's coming.
Exactly.
But that means you need the start of the conversation to be able to build up that context until you get to the difficult part.
And yes.
I'll also add that the context is indeed very important, especially for live communication. For example, in Korean they don't even use pronouns. So even right now, MPL, machine translation for a Korean book, is very bad. Like the performance is really low compared to having an English one, because English is a very specific language. It has pronouns, everything together meaning, whereas in a language like Korean or Japanese or Chinese, they don't have the pronouns most of the time. So it reads very poorly, even right now, the most well-performing models. So it's not been solved yet.
No, it hasn't been solved yet. And maybe computing power, as you said, it may be context. Recently, some of these tools, I've mentioned the coding tools, which is easy because coding is deterministic, and you know what's going on with the code. That's an easier, you could argue that's an easier problem to solve than this, the language problem. As the contexts get larger, I think some of the tools now have contexts up to like whatever, 1 million tokens. Maybe that's not enough. Maybe it's too much because it will cause a delay in the translation. These are all like really, real world problems that have to be solved. I'm sorry my mic dropped, it didn't quite work, but it raised some really, really good comments that I wasn't aware of outside of just the raw coding, which is really, really good, really important. I don't think the solution's there yet. I think it will evolve.
Yeah, and it's my brother deals with this daily. He does educational software for kids, and just implementing predictive text alone is problematic. Even because we're just writing stuff for kids, and it's actually just text on words, but it's also culturally dependent because one word is fine, but 2 words in the right order can have a very different meaning. It could be a very racist remark or the like. Well, it might be completely innocent in a different culture, speaking the exact same language.
Yeah. Oh, yeah.
So he's had to build combination lists of words that are not allowed to go together. Yeah. Yeah.
Good discussion. Yes?
At least I think part of the solution is to train your system on the dialect, just as we did at the time of speech recognition 20 years ago. That's kind of like the way to start, but the problem is there's even more broad. You have a real-time engine, you have an LLM somewhere in the cloud. You need to present that real-time to your LLM. Will you give it in real-time, or will you give it in transcription? Most of the LLMs just take textual input. So already you have to make the prompt. Your voice has to go to text. Yeah, I have a very heavy accent in English. You have not. So what will happen with what I say that goes to the LLM? So it's really, really, really hard to have input that is in one way or another normal.
Yep. You're absolutely right.
So what you're saying is we should all train it on Glaswegians with their terrible English accents.
Actually, we all should speak a standard language, and it would be good.
Or do you use the 80-20 rule? Get this training in the dialects and the words for the 80%, and you were going to the store. Well, you're not going to crawl to. It's unlikely you're going to crawl to the store.
But you can burn the store.
You could burn a store down. You could, you can go behind the store. You could, I don't know. But so this needs some work, and I guess some smart people have to start thinking about it if they want these kind of solutions. Which there are smart people that want this. The live translation. I mean, at some point, live translation is going to be cost prohibitive, perhaps, and you'll be motivated to figure out some sort of an automated tool to do that.
We've got access to the solution for part of it, but we still face these problems.
So you're saying you're facing the same problems that everyone's talking about?
Yeah, exactly.
Yeah.
Some of them not solved.
Not solvable yet.
Make everyone speak one language.
Okay,
desperate to
I don't want to spoil the fun over here. We're already like 10 minutes past, and lunch is already here. So yeah, let's take a break, enjoy the lunch, and next to the food, thanks to Max and Sippy to have the gaming t-shirts with what Maksym showed you before, so don't be shy. Take one from there, okay? And roughly in like 45 minutes, let's be back.
So, I think we can start soon.
I pushed a new version. But yeah, it's like you said, and that's how it should be. I've changed it slightly. And there was something. Very simple expression.
Okay, so it's this one.
Okie dokie. Yet another wonderful lunch. I think in the next 2 months we need all to go to gym or something to recover ourselves after so much food.
Let's start with the buying of a bottom.
Yeah. And now let's continue and see some. All the time security is something you want to learn and be prepared for. So let's have Sandro Gauci. You know him already from yesterday or 2 days ago. No, 2 days ago. And yes, he will of course talking about security and show us some really cool things that you should keep in mind before they hit you. Okay, Sandro?
Thanks, Bogdan. All right, so this one is about the VRTC, of course, the vulnerable RTC, which is this voice over IP and WebRTC purposely vulnerable kind of system that you can run on your computers, your servers, if you really do want to, and how to potentially secure it and make it less useful. Therefore. So this is a 1 hour hands-on workshop. You can participate, but more importantly, we will be looking at different solutions to the different security issues that we have implemented, purposely again, how to solve them, and I hope that you guys can give me the solutions, or discuss the solutions. Because, you know, security issues, they can have different types of solutions, and they might, some of them might work really well, some might introduce new problems, so it's good to make some assessment about this, and So what is the VRTC? I spoke about this on Tuesday, but for those who haven't been here, it's this purposely vulnerable lab. And yeah, I upgraded it since 2 days ago, so there's 0.1, 0.2.1 now. There were some bugs, of course, as usual. Yeah, this is the architecture essentially. You have OpenSIPS on the outside, and there's a big proxy, and behind it there is FreeSwitch, which also talks to SQLite. RTP proxy also talks to dumps recordings, which are PCAPs. So every call is being recorded and put in a PCAP. And these are being exposed by Nginx so that you can see what's happening, you know, as a user running this system. So the idea here is I'm gonna show you the attack working, okay? Then you tell me how to fix it. We decide on which fix to implement. We implement the fix live. Now I'm terrible at doing live stuff, especially with OpenSIPS, CFG, and FreeSwitch. So I'm gonna use a coding agent, like I'm sure many of you are actually now. And then we're gonna verify that the attack no longer works, but also that the system still works, right? there's a lot of security solutions that stop everyone else also from using the voice over IP system. So we should discuss the trade-offs, you know. So now I'm looking for real answers, really. What would you do in production, you know, apart from maybe increasing your bandwidth and using something like Cloudflare? Anyway, so this can be, you know, hands-on. You're very welcome to run this locally. It's on GitHub. I'll show the instructions soon. But yeah, anyone without a working local setup should still participate. In fact, it doesn't matter if you run it locally or not. And if you do run it locally and you find bugs, tell me afterwards, not during the session, or open an issue. All right. So there's no wrong answers, of course, but some answers are more good than others, I guess. So we can discuss that. And the idea is that fixes accumulate like in a live, real environment. Anyway, let's, so we have a number of exercises here. So this is how you would run it locally. You would use Docker Compose, ideally on a Linux machine with host networking. If you use it on a Mac OS or Windows, you should use a Linux VM ideally, because it's going to give you problems with host networking. On Mac OS, I use Colima, but with extra instructions that are part of. I put the instructions in the repository on GitHub. Anyway, once you've cloned it, it will pull the containers, and then you can run these scripts, set up networking, sets the IP address that it needs to know about, you generate random passwords where need be, and it switches on TLS as well, so you need self-signed certificates, or if you're on the internet, you can have Let's Encrypt as well. Anyway, so what are the exercises that we can run? Obviously, we won't be able to do all of them within the hour, especially if I get stuck somewhere. But these are some of the exercises. So there's weak SIP credentials, of course, and there is no rate limiting, so you can flood the server naturally. OpenSIPS, and behind it FreeSwitch. And FreeSwitch, there is the Lua SQL injection that we showed on Tuesday, and I'm gonna show it again today, hopefully. RTP bleed with RTP proxy. I hope that Maksym can help here with some solutions. I did not yet explore the solutions for that in this environment here. And there's more, right? Zip digest leak, recording storage abuse that I described last time, didn't have the video working, and enumeration, and of course plaintext zip and RTP, which you find everywhere. So at this point, I should switch to my console and switch on the Docker Compose stuff. But yeah, in the meantime, we should also discuss which ones we should start fixing. So let's go here. I'm gonna put this. So if oops. I should just do this actually. All right, that's better. So, compose scenario PBX2 fixed. I created a new scenario called PBX2 fixed so that we can work on that. Up, and I can just switch on the whole thing. So as it's switching on, there's OpenSIPS, of course, there's recordings cleaner that is trying to keep things within a certain limit, since we're recording all the time and there's calls all the time. So the VRTC has calls running all the time with BareSIP, so that you can actually reproduce easily RTP bleed and RTP inject without having to run your own calls. So there's test calls all the time. Yeah. Now, I think maybe in terms of where is the browser now? Okay, I quit everything. Huh? Let me go back. Okay. So in terms of potential exercises, probably we should start with the Lua SQL injection, because that was, I think, the one that was most interesting last time. What do you guys think? Yep. All right, let's, so that is here. So first I should, show the attack. And then, so this is how it works, right? You have the dialed, which is appended to the SQL query, which is eventually, so Lua, okay, obviously it was that. So this is the actual, and of course, this is based on the example here, right? So this is something we have seen during our work as well, during real pen tests, penetration testing. But yeah, it looks like this. And one of the main problems here is, so with the VRTC, we're not trying to show vulnerabilities in, say, in specific software, right? In FreeSwitch or in RTP proxy or OpenSIPS, that are like crashes that you're going to upgrade and then it magically fixes them. We're showing things that we actually come across that are related to configuration quite often, that are either configuration related or just, security issues that are real but are part of how we do things. Like RTP bleed, you can't just fix it like that and not have some repercussions because of the way that NAT and RTP proxies have to work around them. So anyway, so that's something to keep in mind here. So the SQL query being constructed is this one, which is then sent to DPH, which is the built-in FreeSwitch connection to SQLite in this case. And what I should do here is we have a lot of exercises. So let's see, SQL injection for, okay. So we have 2 exercises here. I can show the cool one actually. So I'm just gonna copy and paste because I'm quite lazy on screen. I prefer Bash. So we have this Docker compose which defines a testing container, and we're going to use that one. We can also use the attacker container, which is the same thing, but it goes from the testing container is configured to run from within the host itself on the Docker host, while the attacker container is running from another IP. It's using normal, Docker networking so that you can run attacks remotely. But I'm just gonna follow the tutorial here because I'm live on stage and I just want to copy and paste stuff. So, so we have these tools here, SQL map harness that I used last time. Okay, I'm gonna say mode PBX2 because is working with both scenarios. It's going to listen on, it's going to attack the SIP server on 127.0.0.1. In this case, you could do it remotely as well. You don't have to do it on localhost. I should update the exercise at some point. And listen there. Okay, fine. So that's cool. And now I should be running SQLmap, which is this web application testing tool that is really good. It's really mature. And target the harness, which then targets the SIP server, which then exploits this SQL injection by sending these SIP messages with the SIP URI that has the injection, right? And that way it takes a while at first because it tries to get do some heuristics and, determine what type of database, even though we did hard code it here, so we did tell it, hey, it's an SQLite. But it does some tests that take a while. So it starts testing and then it does this Boolean-based blind technique. So it knows if it gets a response versus, say, an error, then it knows, okay, this particular character exists in the database in this particular location, for example, stuff like that. Now, if we don't sleep, all right, it did something. So it determined, okay, it is actually injectable, does a lot of tests there. I'm running with threads 1 as well, which I could have changed, but...
Make it verbose so we can see what's wrong.
Sorry?
Make it verbose. So
yeah, that's a good idea, actually. Let me try to guess if it's verbose. No, it's not. Let me see, because I haven't used this. Repository, if you guys spot the... V, okay, obviously. Put 2 of them. Okay. That's our quickly written harness that is giving errors actually, but it's just a broken code. Not seeing extra details in. Sure. So maybe we'll do that later. Which interface do I need to listen on? I don't really remember right now. I think it was Ian something. But let's do all of these. Let's see if we can just debug in the, there's information here as well. But let's see if we can see the traffic this way. This is not gonna work because we are on Colima. So, no. Sorry. That's why I should be running Linux. Do I have the Sippy dump here? No. Yes. Okay. Is it using? But maybe I should. Yeah, that's better. So yeah, you can see how it's doing these things. So you can see. Let me show you the request, how it looks like. Where is the request? Sending invites, it's quite rough, but it works. And putting those comments there so that you have a space, but you could also use the asterisk 20, actually, that also works, but yeah, doesn't matter. Anyway, let's see what it's doing. Okay, it's starting to retrieve things, right? And it got it's starting to retrieve the information from the master DB of SQLite. And this is a Boolean-based blind. So there are various ways to exploit SQL injection. One method would be to actually, if the application is written in a certain way, you might get SQL database in the responses, right? This is not the case here. It doesn't give you, in the error responses, you don't get any information that is leaked like that. But you can cause it, you can use these sort of, what we're seeing here, and between this and that, and depending on the answer, if it's a true or false, and then okay, this is probably the next character is A or B, and so on and so forth. There are other methods like timing-based, where you run sleep on the SQL database, and okay, if it worked, then it's going to take some time, the sleep time, versus if it didn't. So that's also another way. But yeah, I'm losing my patience. Have you guys seen any of these attacks in the wild?
Usually in the context head or something.
1 equals 1 I have seen several times.
Sorry?
1 equals 1 I have seen several times.
Yeah.
I've seen SQL injections basically on the some specific billing or like this, specific versions.
Yep. Okay. Yeah. They are scanning with these and trying to see if they can produce errors. I have not analyzed any attacks like that recently, but I know that they are going on. And an old friend, he's part of the SIPS community, recently contacted me, not about SQL injection, but about command injection, and some SIP servers got compromised, and then it led to toll fraud, so they lost some money, unfortunately. So it's very similar, but instead of SQL, you have bash commands or just Linux commands, really. Why are you so slow? Yeah, and the user agent as well, you see these things. Let's start discussing the solutions and let it run in the background. So how would you sanitize this? I think one of the problems is that the freeswitch.dbh doesn't really have built-in input validation or escaping. So that's kind of, and it doesn't, of course, if it doesn't have that, it doesn't have support parameterized queries. What we have suggested to our clients is to use a library that does have parameterized queries, but I wonder what you guys think, what sort of solution would you apply in this case? And I'm gonna just go back to the Lua script so that
Use prepared statement.
yeah, but how? Any library in particular, you think?
I have no idea
Yeah,
what to do.
the most official one, right?
Yeah, but we're using C and Postgres
Yeah.
driver, and there's prepared statement on database level, and that's it.
Yeah, exactly.
Here, take everything out of Lua, like direct, because I know, like in FreeSwitch, Lua is like a tricky beast, and better to have everything like let's keep it as simple as possible, and maybe talking only via HTTP to the some like small service aside that will do like proper SQLs and stuff.
That's a great solution potentially. That it might introduce new problems, of course, obviously, because if you get flooded and that query it might generate a lot of connections, and some of them, you get the flood internally as well. Your own servers are flooding internally, so that could introduce those problems. But yeah, it's I like that sort of solution because you can implement. I'm not going to implement it here because it will take until.
No, but I know that, for example, for Lua and FreeSwitch, again, maybe I did not touch that for quite a long time, but when the Lua is hanging on somewhere in FreeSwitch, it just blocks the whole Lua thread, and you cannot have anything. So better like to keep it like, if you need to use Lua, do something and like give it back.
Do something async.
Yes,
and,
async
do
and
it.
give it back.
Yeah. I like that solution. I'm not going to implement that one, but it makes a lot of sense because, like you said, it's and you can implement it properly as well because I don't think this code has been updated for a long time. At least the examples are quite old.
So there's library LSQLite, no?
Sorry?
Can
Yeah, so what we're going to do, I think, is use the library for SQLite, for Lua. I already had prepared in the fixed version docker file.fixed. Here I prepared so that Lua rocks is installed, and then you can from there install the Lite3, which has parameterized queries, and that's a solution that works. The one from Igor is probably better though, so I would suggest that you avoid having direct SQL. Alright, let's implement a solution for .lua with SQLite3 instead of the free switch DBH. Okay. So yeah, let's see what's going to happen there. I did try that out before. And this is still going, but now it's a bit too verbose. I'm using Pi as a harness, but I'm using Codex. Subscription is not being banned when you use OpenAI's models yet. While if you use the subscription from Claude, you get banned, and I can't afford that. But both have their pros and cons. I use everything. So what is it doing here? Alright, I did implement something. We can take a look at the diff. So yeah, the solution is, in this case, is not using the free switch official way anymore. I think the problem, have you guys used DBH? Has anyone used the free switch.dbh? Yeah. What do you think about such a solution? If there wasn't the solution that Igor has suggested, of course. I think my impression is that you lose some advantages that you have with using the built-in free switch way of doing things. For example, the pooling and so on. I think this handles.
It's also prone to error if somebody changes. It's also prone to error if something changes on free switch side. You won't.
So it has problems as well where you're relying on free switch never changing the Lua scripts. Okay, so you saw your Lua scripts breaking because of changes. Yeah, so it has pros and cons like everything. This is a solution that sort of is quickly implemented. Not by me, of course. I would take a whole day trying to figure out everything, but nowadays there is AI. And then if we were to restart free switch, can also do that here. I'm gonna stop the attack then. So there are things that are restarting as well, as a result. Oh, I'm stopping everything. wrong terminal. And this is where the SQL map was running. Alright. So, SQL map is very slow right now, somehow. Alright, let's try to switch that one again. And once it's confirmed to be running, LT is okay, good. We can just, try to run it again without the V's because and of course there was the VoIP method. So the VoIP method, which is 201. And now we, if you remember from 2 days ago, we were generating errors that way. But then if we did, what was it? And it would go through when we had the SQL injection vulnerability. And now it should not go through. It's just early media and then it gives an error. So that kind of, gives us the impression that it's being fixed. One should, of course, debug and make sure everything is going through correctly. Yeah, so you can see that, FreeSwitch is complaining here about these ones here, and SQL map as well. All right. Anyone has any questions about this or any feedback, any comments, something that is bothering you? Flavio, you pulled out your hand, but that wasn't a question, right?
No.
All right, let's move on. Let's look at RTP bleed, because I think there might be a sort of solution to it with RTP proxy. But yeah, wanted to discuss this with Maksym. Maksym, are you available?
Yeah, sure.
Yep. Yeah, so basically, okay, the idea of RTP bleed is that there's these calls going on, right, in the background with bear sip and so on. So, and through RTP proxy and then FreeSwitch behind it. And when RTP proxy gets, when RTP proxy starts, when it opens the port for the media session that is going to happen, the attacker could hit that port before the actual user, before the actual real stream, and RTP proxy might learn the attacker's IP address and port as being, the correct one to proxy to. And that's RTP bleed. The attacker ends up getting the RTP stream. If it's clear text RTP, they can listen to the RTP. If it's not, if it's SRTP, you still get denial of service, and it sucks, right? Because an attacker can scan those ports all the time on your media server, and no one can have a proper phone call or audio or video traffic. So what sort of solutions? I know that RTP engine has different types of solutions and a lot of options, some of which work better than others. But it's kind of a design sort of issue with, what RTP proxies out there are designed to do is to proxy RTP, because we have, one of the main reasons is because we have NAT, and the right IP address is not always in the SDP, right? So let me just show the exercise for RTP bleed here. So okay, so this time we're going to use the attacker shell, so that it's external, it's not on the local host. So this one we can switch off, and we can and yeah, we're going to target IP this variable. There's the right IP there already set. And then we use the RTP bleed tool that we include with the VRTC. Then hopefully, yeah, we get an RTP response. You can leave it running for a while as well, and you start getting different responses for different calls that are ongoing. But these are, they contain some sort of PCMU audio going on. You get the whole RTP packet without being man in the middle, okay? So that's the whole point, right? You can do this against a server in a totally different country where you don't have access to the stream at all. Yeah. So what sort of solutions, so what sort of mitigations can we have? I think we should discuss this. What do you guys say? Or has some ideas, even conceptually? Yeah.
Yeah, conceptually we've been discussing it. I think with Razvan and other people over the years. One solution would be to actually to use RTCP.
SSRC.
Yeah, SSRC attribute in the SDP. So then you essentially can pass it to RTP proxy and say only packets with this particular SSRC should be able to bind the session. It's still possible, obviously, to brute force, but then you have a 32-bit number, so you need to send at least half of.
Then you cause a bandwidth saturation attack.
Yeah.
Because you don't only need to brute force the SSRC, but also the port, right? So it becomes a very large number when you combine it.
Yeah, and usually you have only few seconds to hit this before actual real RTP starts streaming, so it becomes
this could work.
This would possibly, this could have issues when you have RTCP in the middle, or if you have telephone events that are embedded in the same RTP stream, those could have different SSRCs as well. It would also break if you have multiplexing or multiple RTP sessions on the same port, because in that case you would have different SSRCs in both. Then the endpoint may change SSRC for any reason because it is an actually different stream over the same session. It is a different. So that's.
I'm a bit skeptic of that solution, yes, as well. Also because the RFC says that you can change the SSRC when you start a new stream on the same, session. That's kind of, it could work, but it's very specific and it's not implemented in RTP proxy, so we can't implement it right now.
No, right now. So for right now, we only have, I think there is a parameter there, I think it's I think it's called force asymmetric.
Yeah.
That should technically only restrict you to.
Let's see if the LLM can do it.
You will no longer trust anything.
Yeah.
So you will not be able to do proper matching.
So what can you explain a bit more?
Well, then you lose not traversal essentially. Then you rely on having proper
IP on the SDP.
Yeah, and port number.
So this is maybe not such a good idea in practice. I've seen solutions where when how was it? you could pass the SDP IP and then prioritize on that. So even RTP engine does some sort of prioritization. And so you can prioritize on the IP at SIP level as well, potentially, but also especially at the SDP level. And you pass it from OpenSIPS in this case to RTP proxy, which then enforces both the learning and also the incoming RTP stream should also be checked. So, you know, against the learning, because sometimes at least with RTP engine, you can block the learning problem, but still have incoming RTP from a different IP and port, and still be accepted. That's what we call RTP inject, not RTP bleed.
Well, I think in RTP proxy there's a window where you can do that as well, so it's something similar. But of course, within that window, you can't rely on anything.
Yep. Yeah, I mean, yeah, it does definitely learn during that window. So if the attacker doesn't win the network race condition in RTP with RTP proxy, my understanding is that, you know, you don't get the problem, right? But obviously attackers can target the ports all the time, and it's not, you know, it doesn't have to, they don't have to create a bandwidth saturation attack to cause this. So, you know, if they did have to cause a bandwidth saturation attack, that's kind of another problem, right? Which is very hard to protect against. It's something totally different.
Yeah.
Okay.
I mean, some combination could be possible. I mean, not implemented, but over the years it was discussed. Maybe we can sacrifice first 2-3 packets and observe that they arrive at specific intervals, right? Because obviously, if you just spray in the ports, you're probably not going to hit like whatever, like 10 milliseconds between packets. You just so yeah, I mean.
Yep, all right. I don't think I will try to implement that now because we're running out of time and it's.
Just forward this responsibility to customers. Sometimes it's possible and add an additional parameter like ACL and we say, okay, you may still use symmetric FTP, but you have to enter their allowed networks and then symmetric FTP will work if you send it from this IPs.
Yep.
So it's allow customer not completely disable symmetric FTP, but have something in between. Because
yes.
It's only when customer able to do it. If you provide a public service, like
then
so it works for wholesale and interconnection, but not for some soft phone and the user. And also we have some monitoring that like trying to find this IP who continuously sending RTP streams to our port where we are not expecting this traffic. Because we found that usually happens when like someone sending stream continuously because they don't know if there's some call using this port or not. They just send it and that's it. And we can find, okay, on our side port is closed, nobody expect anything, and this IP is sending. So you can somehow have statistics with this IPs and then do something there.
Yep.
Because it's not very reliable because with UDP, attacker in easy way can do IP spoofing.
Of course. There's that on top of the problem.
Still no like single solution.
Yeah, for sure. IP spoofing. I don't know if it's such a big issue in this case, unless, of course, depends on your attacks.
We will just collect the statistics and we will say, okay, we found attacker IP, let's block them on firewall. And if we will do this, then attacker will say, okay, I know way how to block on their firewall side. I just send garbage from
Yes.
IP of real customer, and then they will block their real customer.
Yes. So this is definitely a problem where attackers spoof IP addresses of victims to get them blocked, right? That's what you're talking about, right?
Yeah, but I mean the statistics collected, we cannot rely on this
Yeah.
just to block without checking things.
I agree. So it becomes a bit of a manual sort of thing. Of course there's AI. Sorry. Yeah, all right, let's move on. But yeah, it was a good discussion on this. I'm not gonna, I think we're running out of time, so I'm not going to go into digest leak and so on. But yeah, happy to discuss any of these attacks and vulnerabilities and solutions, more importantly, because vulnerabilities and security issues without solutions, they're the most interesting ones, but I kind of try to always find some sort of mitigation, at least, if there's no solution.
RTP the solution will be ICE, but
yeah.
The problem is that not everybody implements it. Because with ICE, you don't have to fit.
And not only that, but also some proxies that do implement it don't implement it in the way that it was kind of meant to be implemented, and that's why we came across the DTLS hello client denial of service, for example, and also we've seen RTP bleed in kind of connections that have had ICE, but it was just a naive type of RTP proxy, not Maksym's RTP proxy, but a naive implementation that was used for VoIP and then upgraded to WebRTC without, doing what ICE is supposed to be doing, which is to have kind of this channel or this set of tuples that are used to. All right, let's wrap up. What we fixed? Almost nothing. It's hard to do that. There's a lot to discuss, I think. I should promote our newsletter. Every month we issue a newsletter called RTC Sec newsletter. There's only one newsletter that talks about voice over IP and WebRTC security, and that's this one here. So subscribe. I think it applies to everyone here. And yeah, we have a lot of news from third parties and a bit of discussion here and there about the sort of news and what I personally think about how things are going in the voice over IP security world. And yeah, come find me if you want to add some scenarios or have some ideas about new scenarios for the VRTC. It's probably next one is probably going to be one with Janus, so for ComCon. So yeah, that's the next one. But after that, we might add something else. So yeah, and that's my contact details. Yeah, this one is better, I think. All right. Any questions? How are we on time?
4 minutes.
4 minutes, yeah.
Thank you, Sandro. So, yeah, questions. Even so, there was a quite interactive discussion so far. So, probably most of the questions were exhaustive. Anyone? Come on. And the 1, the 2, and the 3, and sold. No question.
All right. Going once, twice.
Yes. Okay. No, I have to admit the presentation was really nice. Oh, okay.
Do you have this example of this attack when there's storage saturation?
Yep.
Saturation when the string has much more bandwidth than we expect.
Yep. I do have that.
Real or?
It's definitely real in the sense that we have been doing it.
No, I mean, in this scenario, a customer should be like legit customer to make a call to us.
Are you asking if our customers are concerned about it?
Like customer doing call to our system and then starting to stream something to VRTC, not exactly audio about 200 megabits per second.
Yeah.
Is it real works like?
It's a real one, yes. Believe me. Yeah, it's definitely real. We have abused this. Our clients have solved it in different types of solutions. Most interestingly would be the sort of problems you might see in LEA, legal enforcement systems which are recording phone calls for supposedly criminals and so on. And yeah, no, this is, I mean, it can bring down your, if you have, and we have seen crappy recording systems that are used by the police, by law, that, yeah, one could bring down like that.
But not also about storage, but also about some CPU.
Correct, yes.
So in this scenario, you have to check timings between packets?
The solutions tend to be specific, but you could apply rate limiting. We've seen different types of solutions, right? In WebRTC environments, for example, we've seen people who were kind of recording the audio itself, like, with a headless browser that wouldn't have that problem. So yeah, it depends on the case, but kind of rate limiting is the type of solution we have seen successfully be deployed. So what am I doing here? So yeah, I'm supposed, this is the video that I had, that I didn't manage to do last time. And you can see, in how many seconds, there's a 2 gig file almost. Yeah, it's a very simple security attack. You could combine it with RTP inject as well, of course, but yeah, there's many ways to do this. Right, any more questions? I think we're out of time. Thank you very much, guys.
Thank you to Sandro. Okay, for the next session, we actually have it's a shared session. We have a duet. We'll start Darius, Stefan from our team, from OpenSIPS. And as I mentioned in the first day, we keep working on extending the community editions based on OpenSIPS. We already have the soft switch, we have the IMS components, we have the AI connector, voice connector, and next on the list it's an SBC. It's not yet public. I mean, we are still working, final tunings, and in order to wrap it up, to be available for the public. So today we just want to show, for the first time, how it works, what's the idea here, and Stefan will show you how easy it is to deploy it, basic setup, and then start working with and adding some enhancements, and later Razvan Crainea will take over and extend even more with some MSTeams integration on top of this SBC. But I don't want to steal Stefan's presentation, so I'll let him doing it. Okay, it's all yours.
Okay, thank you, Bogdan. Hi, I'm Darius, and I'm with the OpenSIPS team since the summer in 2024. So they're almost 2 years. Since that, I worked on the community edition projects, on the SIPSET testing framework, on the new free platform VoIP.OpenSIPS.org, and on other projects. Today I'm going to show you how to deploy the new OpenSIPS SBC Community Edition and how to put it as a front-end for VoIP.apprentice.org. First of all, what are the community editions? They are free, fully functional OpenSIPS platforms provided by our team for community usage. Up to date, we have, as Bogdan said previously, SoftSwitch Community Edition, an IMS, and the AI voice connector that I presented last year at the summit. You can explore them here at communityedition.opensips.org. Yeah, you can find more about them here. We have this upcoming community edition project, an SBC Docker-based platform ready to be deployed. It is made from 4 containers, an OpenSIPS and RTP engine, MySQL, and the OpenSIPS control panel web interface. It has features like NAT traversal, topology hiding, TLS, IP blacklist, mid register, PSTN routing, and core server failure. The architecture is the one that I will show you right now. You need the host with Docker daemon installed. All containers will be running in networking host mode. This is the IP, the public IP that I will use in this presentation. It's somewhere in the digital ocean. So we have these 4 containers: the OpenSIPS, the RTP engine, the MySQL, and the control panel. They all have volumes mounted. The OpenSIPS has a volume for its config file, the OpenSIPS control panel for some database provisioning and for some new tools, the MySQL the same for provisioning, and this is for SBC_DB is for persistence. Yeah, the OpenSIPS will be using these 2 interfaces. The public IP at port 5706 on UDP and TLS, and this another public interface that I will show you later how we use it. Yeah, so the OpenSIPS and the control panel work with the MySQL container on the 3306 port on the MySQL, and the OpenSIPS control panel also sends MI commands on the OpenSIPS container, and the RTP engine is controlled with a next generation NG interface. First then I will show you how to spin up the containers. It is pretty easy. So I looked on the host. I already cloned the repositories, the repository. So we have this Docker compose YAML. Where our services are defined, the MySQL, OpenSIPS, OpenSIPS Kapur, and the RTP engine, and all of the stuff that I told you before. Okay, let's just run it. For the SBC Community Edition, for the SBC, for it to be able to start, you need first to configure some environment variables. Here you must put your IP addresses, and you can edit some other things like some passwords, some users, the port. Yeah, let's see if it started. Yeah, everything seems fine. Okay, let me switch back to the presentation. To test our platform, we use the SIPS testing framework. It is based on Python and Docker SDK. We made some scenarios for the SBC Community Edition. The first one that tests a simple call. The next one that tests the core server failover, some inbound calls from the PSTN, and an outbound call. Some invalid SIP messages, because we must see the SBC filters these messages, and some X-header propagation. Okay, so for the first scenario, I will show you the SIP messages that are transaction between the containers, but also I will show you what you need to provision in the OpenSIPS control panel for this to work. So this provisioning happens at the test time with some init tasks, initialization tasks in the SIPS framework. So you need to define your core servers, and you need to define your domain that must be associated with the set of core servers you defined before. So the register is pretty simple. The caller and the callee send the register to the SBC Community Edition, and then from there they go to the core server, and the reply is coming back the same through the SBC on this interface 5706. Then the invite has the same, almost the same pattern. The message goes through the SBC to the core servers and back the same through the SBC to the callee. Same with the reply. The SBC Community Edition knows how to fail over between the core servers. So when some user registers and the first server responds with an error, the SBC just tries with the next core server. We also have the inbound call test. When a call from, because the SBC works in host network on the host, I created this PSTN exterior and core bridge networks in the Docker with the Docker daemon through the SIPS testing framework to replicate the real behavior from the real life scenario. So for this call to connect, you have to provide in the control panel web interface the following. You must add the gateway. Then you must add some rule in the DID mappings tool that recognizes the dial number. And then the SBC knows how to route the call to the core servers and to the poly. I use this other public interface for the SBC because somehow I needed the core servers to know that this call is coming from the PSTN. Because if I just use this, the core servers will think that every call will come from the PSTN. Yeah. This is the reply. And you can define the DID mapping in various ways. You can change the dial number to some user name, or you can add a domain. You can do whatever replacement substitution you want. The SBC also knows how to route outbound calls. For this, you also need the gateway defined, and you need some rules in the dynamic routing tool. And some rules in the tile plan to match so that the SBC knows that this call is coming from the PSTN. This rule from the dynamic routing tool is to match the prefix with some gateway, also defined in the dynamic routing tool. So what happens is when the invite comes to the SBC, it goes to the core servers, it returns, and here the SBC match this the ID within the tile plan, and then with this rule it forwards it to the gateway. Yeah, here is the reply pattern. Okay, now let me show you how you can use this test. Yeah, you will find these tests in the root folder in tests. I'll show you the VS Code. Here you can configure some init tasks, some cleanup tasks, and any other setting that you want for your tasks. Here I define the networks. And then for each scenario you have to create another folder where you add one scenario.yaml file where you define your task. So these tests will test the OpenSIPS Community Edition, the SBC Community Edition as a black box. So it will spawn some core servers, some UAC, some UAS, and yeah. I already did some tests, but let me run them now. It is actually really simple to run them. We have this shell script that runs a new Docker container with the CGRates platform installed on it. That has this Docker socket mounted, the host Docker socket mounted, so that it can spawn those new containers, those tasks. You can just run this you can tell what test to run. Okay, you can just do this. And you can also see running these tests creates a log folder where you can see what the controller does, what each task does, or what happened if your tasks failed. Let me show you. You will always have this latest folder where you can see the logs for the latest run that you made. Okay, I moved too slow. It's already finished, but I had some problem. Let's see what happened. I don't see yeah. Anyway, I'm lucky that I ran this before. You can also see capture of the SIP messages, SIP traces. Just use the one that works with all the tests. So here are the registers. You can see how the registers, how the register comes from the UAC of the caller, goes through the SBC and then to the core server. It's pretty simple. This is how the call works. You have the invite with the caller's private address, with everything. It goes through the SBC to the core server. And here you can see how the topology hiding works, because as you can see, there is no private address of the caller. The SBC puts himself in the contact, in the via header, also in the SDP. Here you can see how the invite goes to the core server, back to the SBC, and then to the POI. And after that, the replies, and how the call is established. Yeah. Now, I will use this SBC as a frontend for our latest platform, VoIP.OpenSIPS.org. It is a free public VoIP platform powered by OpenSIPS and SIP Hub. It has features like call forwards, voicemails, an API for live calls and for CDRs. Here at web.opensips.org you can create an account and then use it to talk with other users of the platform. You have a dashboard, you can see your registrations, aliases if you have. Here is how to use your cell phone to register in the platform. You also have these tools for call forwarding settings. Here you enable, disable it, some CDR tool. Yeah. Some basic stuff, but I think it can be useful if you want to test something or I don't know. It also has voicemails. Yeah. Here is its architecture. So we on the host we run some source switch with an OpenSIPS, MySQL database, a web interface for control panel, and some other components that we created for this platform. An API for basically the backend for the web interface, and the web interface served with Apache. We also have this OpenSIPS API that knows only about the OpenSIPS tables. Through it, the user portal API can manage these tables and also the MI commands. And yeah, in front of this platform is Nginx setup that knows how to proxy the requests. You can also, the documentation for the API is also available for the public use. I think you can go here. And you can use any endpoint that you want. Let's see if I can log in. Okay. I don't know why this isn't working right now, but I promise you that I will fix this after the demo. Yeah. So to put the SBC in front of this, we must provision the same tools and tables that I showed you that are provisioned in the test, in the SIPSer test. So, okay. Yeah, I forgot about this slide. You must provide the platform in the core servers tool, and you just need to map its domain with the core server set. Then any register and invite from your platform will route to the SBC to through the SBC. Let's see if it works. No, let's make it. Here you go. First, as I said, you must add the core server. Let's use set ID1, VoIP.OpenSIPS.org at port 5060, and that's all I think. You must reload it on server, and then with the SIP mapping tool, you must add the domain. I think it will work both ways, with and without the wildcard. Let's use it this way. Core server group 1, as we set in the core server tool. Okay, and then you go to your soft zone and you use the SBC as the outbound proxy. We must use that interface that I told you about in the beginning of the presentation here at 7506. 5706. Okay, I think it was with the wildcard. Let's see what happens.
You have to remove the 2 dots.
Okay.
You wrote dot dot.
Ah, yeah. Thank you. Still. I got scared. I will use my phone with also with Zoiper to do the same thing, and then to make a call. Okay. Let's see. Here you can see how the SBC routes the call to VoIP.OpenSIPS.org. This is its public IP. So yeah, basically it works. Now let's grade it to be able to establish PSTN calls. must do the same as we did in the tests. Add the gateway, then add some rule to match the ID used. Then the call will simply route. Here the soft switch on VoIP data facilitator will have this mapping. It will know that this the ID is for Darius, and it will forward the call to the SBC with it, and with Darius changed, replaced instead of the ID, and the call will work. Let's do this. I think this is the gateway for their outbound, for their broadbands outbound. And as I said, here you must add the DID. I will add the domain to the DID so that the core server, the VoIP data facilitator, will know that it's a call for a user of its own. Now I will make a call from my phone number. Let's see. Yeah, and it worked. But first, let's open this CGRates. Not this way. The inbound way. Okay. The call established. Let's see. First, the call comes on 5706 interface on the SBC. It goes to the core server using the other interface, so that the core server will know that it is a call from, because it has the same provisioning in the dynamic routing table, using the SBC as a gateway. So if I just use the same interface, it would just simply reject the call. So as you can see, the call goes to VoIP data facilitator, back to the SBC, and to my cell phone on my laptop. Now I want to show you something on the OpenSIPS user portal platform. You can see your live calls here, and you can put them on hold, or you can also transfer them. You can end them. Yeah, it ended. And now, to have a complete platform, we just need to be able to route the outbound calls too. For this, the SBC has to be able to identify the DID as a DID for the PSTN, then to route it with its rows to the correct gateway. The source switch on VoIP data possible.org will replace the caller username with his CLI, and yeah, that's it. Let's do this. Oh, fuck. Got me in the end. Thank you, God. It's confusing because the screen is smaller now in my laptop. Okay. As I said, you have to add the gateway. DID worldwide uses a different gateway for inbound traffic, so I need to add that gateway too. I also need to add the rule, the default group, the prefix. I think it's for 0. It matches the prefix exactly, like the longest prefix match. Okay, and also I need to add the dial plan. Okay, I read the dial plan and hope that the screen sharing will start soon. Okay. I think I did some mistake. So the code goes to webdataconcept.org. And here. So you can see the call goes to the core server. But it's looking for the user with that username instead of routing it with the ID. Yeah, I'm a little bit nervous and I'm not, I can't figure it out now, what happens. But yeah, it should go out in the PSTN and call some robot. Yeah, I don't know if I have more time? No? Okay, now I will let Razvan come and say the day and add some MSTeams integration to this platform.
Thank you, Darius. Thanks for Hello? Okay, so...
Razvan, 1 second. Just because it's not officially in the schedule, after Razvan is done, we have like a short demo, like 20, maximum 30 minutes at the end, from Rocco. He wants to show us something very cool stuff. You know, he said private, no cameras, right? No, I'm not sure exactly what kind of a privacy nature is here, but anyhow, yeah. As far as I know, it's a technical one, right? Okay, so just to know, because again, that was not officially in the schedule, so there will be another small demo after Razvan.
Perfect. All right. So thank you, Darius. Thank you for setting our SBC up. Now what I'm going to show you is how you can integrate with MSTeams. So you have your own platform. In our case, we had the soft switch that we wanted to add some, to put an SBC in front of it. That maybe to enforce some security policies, some filtering, some, you name it, topology hiding, you name it. But you can also enhance it with some extra features. In our case, with MSTeams support. How many of you are using MSTeams? Okay, and how many of you are using it for your daily calls, not only team calls? Oh, there are a couple of you. Okay. Well, using probably you've heard of direct routing or direct dialing. What is it? Direct routing, yeah. You know what it is? It's a way of telling MSTeams that instead of using their own carriers and their own tariffs and charges and so on, instead of using that, just send the calls to your PBX, your carrier, your own SBC in order to get probably better rates, get some sort of extra features, extra, let's say, functionalities. So basically, instead of having everything inside MSTeams, you move or allow, you open path to different different other features. And the way you do this is basically if you start by creating a bunch of, or having a bunch, an organization. First you have to have an organization that you use MSTeams on. In our case we have msteams.ziphub.com and have a bunch of users. In our case, in my organization, it's only me. And you have to have some certain licenses to do that. So you can do that by your own. First of all, you have to have the Microsoft 365 Business Basic. This is the least license that enables you to buy the MSTeams phone standard. So in order to be able to break through different other carriers, you need this Teams phone standard. Once you have this, you can start configuring your voice applications. And in this case, you go to admins.teams.microsoft.com, voice, and direct routing. Here, you will be able to add an SBC. Basically, this SBC is whatever is your system that will be able to get inbound calls from internet calls. Let's see how this looks like. So you essentially just add an FQDN domain name. In my case, it's sbc.msteams.ziphub.com, a signaling port. Whether you're sending and receiving SIP options, this is being used in order to check availability of each other, and certain media capabilities as well, whether if you want to have bypass or have Microsoft handle all the media, all sorts of media stuff that we're not interested in. But first, again, you need to create this setup. Then you need to create some sort of voice route. So basically say whatever your user is dialing, send it to this SBC. In my case, I want to send everything that's a digit. So, well, everything that starts with plus and is followed by a digit, I send it to this, there you go. I send it to this SBC. So let's see how this looks like. Well, you just say, okay, this is the dial number, it should be sent to this. Of course, if you have multiple, you can add more here and organize them based on this priority. But I only have one. And that's more or less it. Well, you may also, in case you have different policies, for example, you have local dialing, you have international dialing, you can create different profiles and assign them to the user, but I've done the simplest provisioning stuff just to make it work, and it wasn't simple, trust me. Anyways, so this is, in terms of Teams, this is what you gotta do. There's also a blog post that Alexei wrote a couple of times. How many years back? Anyway, 7 years back. So there's a blog post that can guide you with all this setup. Things have changed since then, unfortunately. But yeah, I could pick into that blog in order to set this up. So having done all these settings in MSTeams basically just allows you to use your own SBC, but that's not it. In order to use your own SBC, you have to comply with a lot of rules that MSTeams enforce, and they do enforce it just because they want to. It's, for me, to be honest, they are not all of them make sense, but they are there. So if you want to integrate, we need to do that. So let me get back to Darius's SBC. So we're using the same instance, the same Docker instance that we left off. In order to, I will split this presentation into first for inbound traffic and second for outbound traffic. I have here a special branch that I created. Okay. Okay. first, let's handle options, right? So as you've seen earlier, the SBC is able to send options, and if you're not replying to them, you will see here that, where is it? Here. No SIP options within the last 15 minutes. That's because we did not have anything enabled in our SBC. In order to be able to use MSTeams, we will set up MSTeams as a gateway, right? So instead of whenever we receive calls, we will treat MSTeams as a gateway. We will assign a couple of the IDs to it in order to route the traffic just as you would route to a gateway, except it's a bunch of MSTeams users, not phone numbers. So let's do that first. SBC MSTeams .com. Right. Going here, dynamic routing. So we will add another gateway, let's say MSTeams. Now, in SIP address, for one of the requirements in order to use MSTeams is to send them to any of the IPs that they provide. And that's behind a special FQDN, which is sip.psdn.hub.microsoft.com. Another requirement is to always send it over TCP, over TLS, sorry, so we have to have the transport TLS. We always have to probe, we always have to ping. If we don't ping, we will see this error, right? So if we don't send the ping within 15 minutes, so that's why we will always have to ping. And yeah, this is the bare minimum that we need. We reload. There we go. Oops. The gateway is now enabled. Let's go back. First, let's go back to the script. So these are the changes that I've made. Now, another important thing in order to work with MSTeams is to always use your own FQDN in the contact header. So, whenever we are using TLS, I used an advertised domain and port in order to make sure that all my outgoing outgoing contact headers are actually an FQDN, a domain name, and not just the IP. I'll get back to DB text. Here I set up TLS server and a TLS client. Another requirement from MSTeams in order to be able to use it is to have like a valid certificate that is trusted by publicly trusted. In our case, I pre-generated a let's encrypt the certificate and uploaded it on the server. Here, tracer, this is a nice hack that I'm doing. In order to be able to spot the TLS traffic, I didn't want to set up a Homer instance and so on. It was easier for me to just trace all the traffic to a dummy port. So what this does is it will trace all the traffic to localhost port 9, which no one is listening, but helps us see that traffic in plain text. I'm doing trace in order to actually see the traffic. And then the simplest thing that I want to do is whenever we have a call that goes that is routed to an MSTeams, in this case, the gateway ID is MSTeams, just as we added it here. We called it MSTeams. So if the gateway ID is MSTeams, we just set a flag and set the TLS domains to be used for MSTeams. Another thing that we need to do is to change the to header. So another requirement from MSTeams to
route the calls correctly is to have the your domain, your FQDN domain, in the to-header. I would say that's all of it, but it's not, because there's one more restriction. MSTeams always wants the media to be encrypted over SRTP. So that's why I'm actually setting this flag here, so that whenever we route, this is branch route, say, whenever we route a call to MSTeams, we also have to have RTP engine translate from RTP to SRTP. And this is what this line is doing. And we're actually almost done. I'm saying almost because remember I was saying that MSTeams require some pinging, and on top of that they require it to come from a trusted TLS certificate, and also to have your the correct FQDN in the contact header. OpenSIPS does not generate options with contact header because, well, it's not needed and nobody uses it. However, MSTeams wants it. So that's why we hook in the local route, we hook on top of the options method and append FQDN contact so that MSTeams are happy to with our options.
So if you will ping other domain with options, it will also treat it as MSTeams.
That is correct. That's Igor already spotted a bug in my script. Of course, this is just proof of concept because I only have a TLS, the MSTeams TLS gateway. But you are absolutely right. But of course, it's quite simple here to also check whether the gateway is MSTeams or whether it is going to sip.pstn.msteams.microsoft.com. So, well, there are ways of filtering that. I actually, my real script does have it, but I skipped it here. I can put it here. It's just a line. It's just another end. So sorry about that. These are the certificates. Please don't copy them. Okay. Okay. And there's one more stuff that I mentioned. The DB text here. This is a hack. There's another requirement, let's say from MSTeams in order to work. They will be sending some pingings, and you have to accept those pings. But they are saying they will be sending the pings from any of the address that results from sip.all.pstnhub.microsoft.com. Probably Igor, I think, knows there's a limitation in OpenSIPS that you can't verify. There's no transformation or script that allows you in OpenSIPS to verify whether an IP is part of FQDN, let's say, resolution, right? So what we've done here was we put in dispatcher, we created a special partition and put this FQDN. Why we did that? Because the dispatcher is able to expand the FQDN and learn all the IPs, the real IPs that the messages may come from, so that whenever we do DS is in list, they will say, okay, this is a real, and it's coming from MSTeams. So that's why we've done that. All right. So now we have this script. I will just restart OpenSIPS and see how it's going. Let's try to start on this and break. What we should see now, well, except of a lot of flooding from I don't know who, you can learn those IPs as well and start flooding them yourself. You can do that. We should be seeing some some pinging. I believe it's configured to be sent like 15 seconds. Yes. This is one of the options that OpenSIPS has sent to MSTeams. How do I know? First of all, well, it's the domain, so this is where it's going. But there's also, as you can see, we can only see that it's going to 127.0.0.1. This is exactly the hack I was telling you about. So we've done that in order to see the traffic, right? We don't see the actual traffic, the TLS traffic, because it's encrypted, so we cannot spot it with SMGrep, at least not without giving the keys and the certificates.
HAP and see the correct addresses and just expose the HAP and listen on some.
Oh yes, we could have sent HAP. It does receive HAP, right? SMGrep, I remember. Yeah, we could have done that as well. Okay, and as you can see, we also get a response, 200 OK. The server is microsoft.pstn.cipproxy. This is the region ID, so because they have several regions and each of them has a unique ID. Well, in our case, the Western Europe probably responded because this server is located in Germany, so it's quite close. But yeah, this is a response to our options. They should be sending some options on by themselves as well, but I'm not seeing them right now. Not sure why. Probably it takes some time. I mean, you might have experience, but things don't propagate instantly on the Microsoft side. I was joking with Alexei yesterday. Whenever you make a configuration, there's a warning saying this doesn't take effect immediately. You might have to wait 24 hours. So yeah, good luck with that. Hopefully it won't be the case. All right, let's see what happened here. Let's refresh. We still have some issues, and it's still not picking up like anything. But the good side is that we have probing. We should be seeing some probing from the other side as well. Not sure why we're not. Okay, so what we've done so far is to sort out the inbound. This means that we will be able to place calls to MSTeams. I forgot to say, another important thing you need to do is for users, you have to assign a DID. You have to assign a phone number to a user. Otherwise, it will not work. That's because it is going to use that phone number as a CLI whenever you place outgoing calls. So you really need there's this requirement to have a user. So now, if I dial on the SBC, if I dial this number, my MSTeams should be ringing. I have here my MSTeams client. It's in browser. I also have a user registered on the SBC. So actually, there's one more thing I forgot to do. In dynamic routing, I added a gateway, but I didn't route anything to it. So I need to add a rule saying that whenever I dial 403122, this is my phone number, this is my MSTeams phone number, I should be routing it to MSTeams gateway. Okay. Okay, and now I'll place a call from my Zoipar, which is going to go through SBC and okay, something did not go right. Did things ring? No. All right, let's see what's happening. So this is me. I called MSTeams, it authenticated me. This is another try, and I get forbidden. Who's sending me? The soft switch is sending me forbidden. Okay. Just a second, because I think it should have gone to. Let's check the script. Perhaps I have a bug in it. All right. So it's not from core. It should be from. Actually, it should be from user. Darius, you see here. What's the routing on the soft switch for the PSTN? Do you have any idea? No. All right, we shall check then. Sorry. The same? Is the SBC, but what, is there a prefix or something? Because I'm getting a 403. Did you change the ACLs or something? No? Actually, no. It should be fine. Okay, but with our registration. All right. Oh, that might be the reason. Registration failed. We should see some registration, but we're not. Where is that? All right. Ready. Let's try again. It's another call. Temporary unavailable. Seeing that. Thank you, Margaret. Let's see. Okay, who's unavailable? Oh. Or to no, this is Marvin's call. Let's try to place another. Register failed with temporary unavailable. Routing to user. Let's check something else. So it's from carrier Yeah, she's not from here. Bear with me a few moments, please. Okay, so we get a response back from Quote. Oh, right. So, yeah, there's another. I forgot to do something else. So we need to do some filtering. So here, what was it? We need to say that. So when it's coming from core, we need to send it to PSTN, and in order to do that, we need to add a rule here, the plan ID 1. Whatever starts with lots, let's say, or 40. Yeah. Let's try one more time. Hopefully this time it will go to. Right, same thing, right? Yeah, so it's trying to route it as a user and it shouldn't. Why is that? Oh. This should be a SIP. Alright, now it's raining. There you go. Right, so. Hello? Hello? 1, 2, 3. I cannot hear you. Hello? Let's check. Hello? Hello? Okay. That is. Hello? Hello? Hi. Hello? I think somebody's stealing my audio, actually. Hello? Hello? Feedback. It's still muted here. Oh, it's not. Okay, so as you can see, inbound works now. Well, I had some trouble setting it up, but it was my audio. All right. So we took care of calling in. So whenever you have the ID assigned to your MSTeams, now you will be able to receive calls on your MSTeams platform. But I think it would be more interesting the other way around. from the MSTeams platform to be able to call outside. So this is the outbound, and we will handle it now. Sorry?
Share invite content you send.
You want to see the invite? Oh, okay, sure. No, actually it was here. It's here. Let's see which one is it. Okay, we've got a ringing. This is the one. So as you can see, it's going, of course, we don't see the real address, we just see our local interface. This is the way it looks here. So this is the ID that we are calling, the to header. The most important is the contact header, which consists of the FQDN of the server. So if you don't put that, nothing will work. And also the SRTP. Here you have the keys for SRTP and everything. So it's not a small package.
Your system processing refer requests?
Sorry?
The system process refer requests?
If it processes what? FR request?
Refer.
Oh, refer. No.
Because when you send the samples, you send all header or the all use refer. When Teams user redirects someone inside of
That's true.
CDRs, you will receive refer.
Yes, so by default, actually MSTeams handles transfers and everything using refer, but especially if you say you support not replaces, if you allow refer, but they do work if you strip those. Not sure if you've tried, but if you strip those, they have some other ways of handling that as well. Using reinvite with replaces, yeah.
Making new call without. If you will remove refer, they just making processing transfer on their side and you receive new call.
Yes, but not all the time. I've seen. I don't remember exactly because by default they do everything using refer, even music on hold. So if you put the call on hold, they will try to transfer it to. I don't know, to a media server that is somewhere in their platform, but so using a refer. But yeah, we should remove them. It's not part of this demo.
We have different experience with two header. We're just not doing this and it works. We are not replacing domain, it's a header. Actually.
The domain here? Or
in two header, sorry.
Oh, in the to header, okay.
Okay.
It might not be required, yeah.
Also you can put just IP address in contact if you have route, record route, and domain name in your route header.
Oh, okay. So, yes, that's correct. I think that's the way the blog was created. For us, it was simpler to put it like this because we just added as without adding a route preset. So we're just doing some sort of topology hiding using this contact, and that's it. Exactly. If you do topology hiding, yes, you have to do this because you have no route. So yeah. All right. Now let's see the outbound. Basically, what I have here is just this small snippet. So again, I try to keep it as simpler as possible for it to work. Of course, there's no multi-domain, there's one single domain you might have noticed. Certificates are stored in a file, they shouldn't because especially if they are Let's Encrypt, they are only valid like 3 months and you can't afford offering a service just for 3 months. So you'll have to put them in database, reload them whenever they change and so on. This is just a proof of concept that I've done yesterday, so bear with me. It's something quite simple. The only thing that we need to do on the outbound is to detect it comes from MSTeams and make sure that we translate from SRTP to RTP. So this is the only thing that we do. Basically, change the RTP flags we are passing to RTP engine. That's it. Let's see how this works. I have here the ID which is mapped back to, I believe, to Darius's phone. Yeah. It's the same DID that he was using. So let's see. Okay, they couldn't connect us. Let's see why. Okay. So now it's a call coming from SBC. Did I restart OpenSIPS? Yes, I did. So OpenSIPS rejected this call. Let's see why. Okay, this is a register. I'll try again. Actually, it seems it's not even. Oh, it's ringing? It does look like it's ringing, but I see no. Let's check. Let's try again. Okay. Hello? Let's see whether it's my. Can you hear me? Okay. There's nothing muted here. Okay, so I think the HDMI is stealing my audio, so apologies about that. Yeah, but more or less that was it. So we were able to. Did you turn off the call? Okay. Yeah.
Would you consider using the audio jack?
Oh, the audio jack.
Yeah, sure.
Yes, let's try. Calling once again. Okay, that was it. Thank you, Livio. Hello. Hello. Okay. Bye. Thank you so much, guys. We still have like 2 more minutes for questions. If you have any, go ahead, German.
How would you do this in a multi-tenant setup?
That would make things a bit more complex. That's because you want. So, for example, you may be using different sockets for different tenants. That will not make them dynamic unless you are using dynamic sockets that have been added in 3.6. But if you do that, you can basically have different ports assigned to different tenants and advertise a domain for each of them. So that's one solution. Another one is to modify the contact dynamically using and pass to the dialog the capital A and lower A flags in order to learn the advertised context for that dialog from a special AVP. So that's another way. There's also some stuff that, it's multi-tenant, it depends on the certificates that you are using. If you're using wildcard, you have to use a server name and advertise server name. So there are some challenges, but they can be solved in different ways. We've done it in several setups, so they can be worked around. Thank you. There's one more question. Go ahead, Mitch.
It's about your experience. Do you maybe know limits on Microsoft side with these options? Because when we have multiple runs from same IP and sending options from same IP to Microsoft side, sometimes you're receiving temporary unavailable to these options. Service still work, but it doesn't look good, especially if you're monitoring these responses somewhere in monitoring alarms appear. So maybe some known numbers, how much options you may send during, second, minutes.
To be honest, we haven't experienced that. So we're not operating the platform, so we're not tracking that. But one of our customers is using it with at least 10 tenants. And
like 10
10 different
SBCs?
not SBCs. One SBC behind several tenants. Each of
You mean this 10 trunks on Microsoft Teams side?
yes.
No, this problem start to appear when you have like hundreds trunks.
Oh, hundreds of trunks. So I did not get into that.
But you can use like bigger trunks. One trunk. That's
Bigger trunk?
Microsoft has its own.
Yeah, Microsoft has some sort of a hierarchy.
As a story. I know about it.
But however, I've also noticed, but I did not use it, you can disable options. Well, but at that point you won't be able to track anymore, you're right. I mean, if you really need to track it, then...
This is new setting.
Probably they change it, like I did the same thing 3 months ago, it was completely different. Let me, no, there is something.
I have one more question, maybe someone has experience with similar Google service called Sippy on Google Voice.
Google Voice sibling, frankly, no, not yet. But probably someone else.
There is a nice document on the website of AnyNode because they are certified SBC for Microsoft Teams. And those guys have a real good paper how you should set up.
Oh, okay. So any nodes you say?
Sorry?
Any nodes?
AnyNode, yes.
Any nodes.
It's a German product. It's really good. And it's certified by Microsoft because back in the days you had to be certified to be able to set up the connection. So yeah.
Okay.
If you don't get any support from Microsoft, if you're connecting with any kind of software that they don't support.
They don't do that now, as far as I know. I mean, we're not certified and we don't get support. All I've done was just reverse engineering and yeah. Alright guys, thank you so much for being here and thanks for staying at my talk.
Thank you, Razvan.
To be someplace you want to be. But other than that, I want everyone to put their hands together for the OpenSIPS team and Bogdan for making this possible. And one more round of applause for Max for doing all the video. That's right, put your hands together for me. Thank you, everyone. I hope everyone gets back safe. For those of you that are staying tomorrow, good luck. You're gonna need it. And that's it, folks. That's the end of the 2026 OpenSIPS Summit. God bless you all.